All right. Hey everybody, my name's Nick. I'm a developer from XMTP, and today I'm going to be showing you all how to build your bot army with XMTP. So first, let's back up. What is XMTP? It is the secure messaging network for Web3. And so what problems is XMTP designed to solve? In the Web3 world, there are some problems that anyone who's built a dApp has probably experienced. It's hard to reach your users if all you have is a 0x address. If you're a creator in Web3, you can't interact with your audience. Maybe you sold 10,000 NFTs, but how do you actually talk to them? How do you get feedback from them? And users can't reach each other. We see decentralized marketplaces, but there's no chat button. There's no way to communicate between different participants in this on-chain economy. XMTP is also designed to solve some of Web 2's biggest problems. In Web 2, messaging is siloed inside each app. I can't send a WhatsApp message to Snapchat or a Twitter message to Facebook. That's because you don't own your messages. The apps do, and they want to control them very tightly. So XMTP was created with composability and interoperability in mind. As you can see here, these are 3 different apps on XMTP, and you can have one inbox shared between them. You can send a message from Coinbase Wallet to Lenster. You can use Converse to see the exact same inbox as your Coinbase Wallet. And that's a really powerful unlock for developers. It means anyone getting started can have access to the inbox of their user, even if they've been using Coinbase Wallet for the last year. You know, if you have a better app, it's really easy for people to switch over to yours. So if you want to say hi, you can scan one of these 2 QR codes. One's for Coinbase Wallet, and one is for an app called Converse. And just shoot me a message, and I can pull it up on the screen here. Hold on. Let me go back. All right, somebody's got to send me a message. Oh. There we go. So this is our example app. XMTP is not in the app business, but we have a nice little web example at xmtp.chat, just so devs have something to play with. So I want to show you a few of the apps built on top of XMTP. This is probably the biggest bot army on the network right now. Coinbase launched on-chain summer in August and built a massive list of users on the XMTP network. They were getting drops every day for new NFTs to mint, and you could actually mint an NFT in like 2 taps from getting a message, so it became really popular. Orb is one of the most popular apps in the Lens ecosystem. All Lens apps use XMTP as the default messaging layer. And so if you have Orb, you have XMTP on your phone, even if you don't know it. At this event, we're launching a new bot that you can actually order toothpaste, deodorant, Red Bull, anywhere in this venue on XMTP. You can come by our booth, scan the QR code, and then order anything day or night, and we will come deliver to you. This is powered by ENS and an app called ChainJet that built the bot framework for it. Very cool, highly recommend you try, and pretty much everything on the menu is $0. And you know, biggest launch of this summer, we launched messaging inside Coinbase Wallet. So anyone who has access to Coinbase Wallet can actually have an inbox and send messages inside Coinbase Wallet. Converse is an app based out of France. They have a really cool feature where they can do matchmaking based on your on-chain interactions. So they'll look at your Farcaster or your Lens social graph and tell you who you should be chatting with. Very cool, highly recommend you try it out. And there's actually, you know, hundreds more apps built on top of XMTP, including a whole lot that came out of hackathons just like this one. The reason we have so many apps is because this is designed to be a simple protocol for developers to pick up, send, and receive messages. You can see a bit of code here. This is really all you need to do a full round trip on the XMTP network. Create a random wallet, create a client, start a new conversation with some address, read the messages, send a message, and you can listen on a stream of all messages. And that's kind of all you need to build any sort of a messaging app. But what we found is that when you're building a bot, you have more demanding needs. And so we wanted to build a framework to allow any developer to build a really high quality bot. Bots are an essential part of any sort of messaging ecosystem. dApps use them to keep in touch with users. They can connect from your wallet to all kinds of services like ChatGPT, and allow you to build really complex workflows without smart contracts or needing a lot of complicated on-chain code. You can just spin up a bot, write JavaScript, and have a very sophisticated application. And so that's what we're going to do today. Yeah. This Botkit Pro was released last week, but I think you're the first people to ever look at it since we kind of soft launched it. But it's designed to just make building a high quality bot dead simple and follows all the best practices that we've been educating developers on for building a good bot. So I have a replit. If anyone has their laptop and wants to follow along at home, you certainly can. And then I'm going to run you through what it looks like to build this bot. I'll give everyone a second to take down the address, then I'll pull up the code. So this is the simplest bot you can build with XMTP. This is all you need as a handler for the bot. It's just going to reply GM anytime a message comes in. We have this run function that lets you pass in that little bot here and connect to a database to store the messages and allow you to resume if your bot gets interrupted. It can go back and fill in missing messages, which is a common pain point for people who are trying to run actual bots in production. You don't want to miss anything. Gives people a bad user experience. So we built this to smartly just pick up where it left off, fill in any missing messages, and send replies. So we can actually run this bot in the terminal right here. All right, and this has printed a QR code of how to message this bot. If you want the very exciting experience of getting a GM back from this code, you can scan the QR code right now, shoot it a message in Converse, and hopefully this will work. Oh, I see messages coming in. So sending a GM, that's good and fun, but a lot of people want to build much more sophisticated things inside of their bots. And so we're going to run through a more powerful example using some of the advanced features of XMTP. XMTP has a notion of content types. And so in addition to text messages, you can also send images, videos, you can send reactions and replies. So we're going to use the remote attachment codec, which lets you upload media, and a number of XMTP apps already have built-in support for the remote attachments. And we're going to use that to do a GIF search bot. And so let's make sure this thing runs. So let me show you what the code for our GIF search looks like. This is the bot handler, so this is all the code that will run every time a message comes in. And so it comes with the XMTP message that was delivered. Message content property is going to be the text. So someone's going to ask for a office GIF maybe. So search query is the office. I wrote a little wrapper for the Tenor API, and so we're just going to search Tenor, which is free GIF search engine, and get back the URL to GIF. Since I don't work for Tenor, we're not going to go too deep into that. Once you have that, we got to create an attachment. Attachments aren't actually stored on the XMTP network. We're kind of designed for small, lightweight messages, and movie files or multi-megabyte GIFs, not a great fit. And so what we do is we actually upload this to IPFS, and then we have a pointer to the encrypted file on IPFS. So the file's public, but no one can read it except for the recipient of the message that has the decryption keys. So I can run through the code here for creating an attachment. So we're actually going to download the file, so we have the bytes. We're going to create this encrypted attachment where we have some very nice helpers built into the codec. This is all a package called XMTP, content type remote attachment, which you can use to send files, movies, whatever you want on the XMTP network of unlimited size, since you're going to store it somewhere else and you just have to take care of having enough credits in your IPFS token. So you create this attachment, and then we can send it. And so when you send something with a custom content type, you just have to specify what content type it is. That also comes from the XMTP content type remote attachment repo. And you pass in that attachment, and it'll send that reply. So we're going to restart this bot now with the GIF. I'm going to turn off the GM bot. All right, and we got a new QR code. This bot's going to be on a totally different address, but let's see if it can actually send you a GIF.
What did we ask
you? You can put in anything you want. It's going to search Tenor, which is the equivalent of Jiffy, get you back a matching GIF. So, yeah. All right, so we have 5 minutes left on this talk. I want to, open things up for Q&A. What can I answer for you about XMTP? Shoot. Not currently. They have their own kind of custom. Oh. The question is, does Farcaster use XMTP? And the answer is no, they have their own kind of homebrewed DM solution. If you think they should use XMTP, love it if people, get vocal and in their face about it. We certainly have a lot of chats with the Farcaster team. I think everyone would love to move to a single interoperable standard. I think they'd like to see that there's support from their users as well. Yes?
You said that the attachment gets encrypted and it's only accessible by the receiver.
That's right.
Can the sender also access it later?
Yes. So the way that it works is we just generate a random encryption key on the sender side, and we send that as a message along with the URL of the encrypted content. And so both sides who have access to that message have all you need to decrypt the content. And so you can see it as well. Yes? Oh, what about heavy files? So in the case of remote attachments, storage is handled off of our network. And so you can make it as heavy as you want. Obviously, it's going to be a strain on the recipient if you have, a 5 gigabyte file. We tell app developers to make it an explicit action to download the content so that you can't just accidentally download a 4 gigabyte movie on your phone if someone sends it to you. And that's kind of a good UX practice. But us as a protocol, we don't specify that. It's just what we tell developers to do. And if you look at most apps in the ecosystem, they will try and do that. We also do include the size of the file. And so you could build an app that would download something if it's under 5 megabytes and then ask you to download it if it's over 5 megabytes, something like that. That's all possible. All right. If there's no other questions, we will be at the booth right next to base and the EF and ENS, and you can come by anytime and ping me for questions. I think this Botkit Pro is going to be a fun tool to build hackathon projects with, so I hope to see a lot of people trying.
Is there an environment you recommend for it?
The question is there an environment we recommend? I am, the developer of this Botkit Pro, and it's very new. It works definitely on Linux and Mac OS. Windows, your mileage may vary, but I'm happy to help you work through whatever issues there are. It's a simple Node.js app. It runs in Docker too, so you could definitely make it work inside a Docker container. All right, thank you, everyone.
So, hi everyone, my name is Simeon. I'm integration lead for Neon EVM. So, how many of you are developers and hackers here? Are there any hackers? Okay, nice, nice. How many of you use Hardhat development framework? Okay, only a couple. How many of you use Foundry? Wow, a lot of Foundry users, okay. That's good. And yeah, today I will talk about what Neon EVM is and how do we help scaling Ethereum dApps. So I guess for all of you happened a lot that you want to swap your 10 USDC into some shit or scam coin on Ethereum, and basically at the same time some degen NFT collection is out and trending and everyone tries to mint it, and basically gas fees are going to eat like all of your 10 USDC that you have saved for months, and I think that's pretty bad. And one of the main, I would say, disadvantages for Ethereum is that one trending dApp can congest the whole network. And this actually is not really beneficial for all users. So what did we build in Neon EVM is we built an EVM that is using the architecture and basically execution layer of Solana. And a lot of people and hackers asked me, is it a layer 2? Is it a layer 1? Actually, it's not it's neither a layer 2, it's nor a layer 1. It's actually something in between. And let me just show you a quick slide of the architecture. So as you can see, Neon EVM is actually not anything more than just a smart contract in Solana that can execute EVM bytecode in Solana virtual machine. So we have built a smart contract in Rust that understands of EVM bytecode and can execute this bytecode without the Solana virtual machine. But with only having this smart contract, basically we can't really bring up Ethereum developers and EVM users because basically they would need to change their tech stack, and Ethereum users can't really use MetaMask or their EVM wallets. So we have also one more pretty important component called the EVM, called the Neon proxy. And as you can see, the Neon proxy on the one side actually accepts Ethereum-like transactions. It provides just an Ethereum RPC API, and on the other side, it unwraps the Ethereum transaction, creates a Solana transaction, and calls our Neon EVM program inside it. And you're gonna ask, okay, how do you, for example, solve scalability issues? And it's simple. It's simple because of Solana parallel execution. And actually, how Solana works is that, let me just show you one more slide. Yeah, I think Solana is actually stateless. And basically, when constructing a Solana transaction, this is actually what a Solana transaction looks like. And as you can see, below the header, we have the account list. So this account list basically defines all the accounts that are going to be read and written to for this transaction. So if we have two different dApps, let's say we have one DEX and one NFT collection, and if the same, if we have two same transactions posted at the same time, those transactions are going to be executed not sequentially, but parallelly. And that's actually the whole example that I gave you, that one dApp cannot congest the whole network, actually holds for Ethereum but doesn't hold for Solana. The gas prices will go up only for that app, but for other dApps, the gas prices will remain low. And this is something that you can actually use. And also, let me just go to the other slide. So we enable developers deploy on Solana, but without changing their tech stack, the same as users. They can use MetaMask, they can use their EVM accounts. So if you're using Hardhat, if you're using Foundry, it's all right. You just change the RPC to our RPC and you can deploy. Another good thing is that our main aim is to become fully interoperable with Solana. So for now, we only showcase, and I'm going to show you how we can deploy a Solana SPL token with as a wrapped ERC20. And basically, you can underlyingly mint, you can underlyingly transfer from your MetaMask an SPL token, and you can use in your dApp. So let's just go and see. This is just a very, very simple Hardhat project, and this is the interesting part. So you can see we have a token that is called ERC for SPL, and you can see something very interesting. Here are the two Solana token programs that are basically, Neon EVM has a precompiled contracts that can interact natively with Solana, SPL, and Metaplex. And you can see we have wrapped the whole ERC20 interface with calling the underlying SPL token. So we also have we also have a deployment script. You can see, so what the deployment script does, it deploys a token, and then after that it mints to the deployer account just 100 tokens. So let me show you, let's just run and wait a little bit. Let me just show you what in the configuration we have to do. Basically, as you can see, we only add Neon DevNet as another network. If you go to Neon Docs, you can see that here are all the materials, so you can see how to configure and use DevTools. We have the Neon faucet. Basically, you can connect to your MetaMask, just request 100 tokens. You're going to see our MetaMask. Yeah, we have received the tokens, and yeah, you can just go ahead and deploy. So our token is deployed. If we come and see let's find Neon Scan. Yeah, so this is our native explorer. So if you go to DevNet, okay, and now you can see that we have two transactions. The first is contract created, and the second one is mint. Basically, we can also, if you want, we can basically verify our contract. Let me just see. We need the four parameters. And we need the deployer address. Let's just take it from MetaMask, because that's the deployer. Okay, so now we should verify our contract. Again, it's the same as verifying with EtherScan. Okay. False, bytecode mismatch. Maybe we need to, let's trench. Okay. Anyways, let's just not lose time with that, and I want to show you some interesting things here in this transaction. So if we come and basically add our token, I guess the problem here is in Hardhat some cache. So if I had just cleaned all the cache and artifacts, maybe it will work. So it's not a big deal. Let's just add our token in our okay, you can see we have the token, and we have 100 tokens. So the most important thing is that you can see the transaction hash, and you can see we have one underlying Solana transaction, right? Because we have deployed our contract on Solana. And it's an actual, if we click, we can basically see that this is the Solana Explorer, and we can basically see that we have minted 100 tokens on Solana, on SPL. So that showcased that we have actually interacted with the Solana SPL program. And let's just try to, we have the token here right now. Let's just send it to, let's say, this account. Just copy this account. I just send 50 tokens, yeah. So right now, we are transferring from one account to another EVM account, but underlyingly, we will also perform the SPL transfer in Solana network. So it's confirmed. Let's see what happens. So this is the transfer. As you can see, we can see from that we have transferred, and also we have one underlying Solana transactions. And the Solana transaction actually transfer from this account to the other. As you can see, this is something interesting. Here the addresses are the same. But actually the transfer from and to is actually in this account metadata, because basically Solana is a little bit different than Ethereum. Solana is stateless, so I can show you another slide. This is a typical Solana program. In a nutshell, Solana is like a big file system. So you have two types of accounts. You have program account and you have a data account. So you can see that a Solana program has some executable BPF bytecode, and we have a flag executable. So this is an executable stateless contract. And how does the contract create a state by itself? Is it creates a Solana data account for itself and actually saves the state there. So basically how Neon EVM works is basically Neon EVM is a stateless smart contract that can execute bytecode. And you can see we have Neon account, which is like an externally owned account, which is like a data account. And inside the data, we have all the Ethereum metadata. For example, Ether address, nodes balance, and so on. And for example, Neon EVM can deploy another contracts, and the same those contracts, when they want to save their state, they create themselves another data account. So that's pretty much it. I think we have 3 or 4 minutes left, so I'll just leave it for some questions. So as we can see, we have native interoperability with Solana, but in the future, we will try to achieve a full interoperability. So the developers can use any contract, can integrate with any Solana smart contract only by using Solidity and using their EVM dev tools. Yeah, I'll leave some time for questions if you have. Maybe something interesting, like we have all the most important materials here in our docs. We also have some tutorials, how to deploy with Hardhat and so on and so on. So, you know, it doesn't really matter how, if you want, you can just start as a beginner and just deploy on Neon EVM. It's not that hard. Maybe I can share something interesting, that we are almost going to start and introduce support for Solana NFTs. So for builders that are interested in some Solana collections, they can deploy their dApps on Neon EVM and basically use their Solana collections soon and introduce them to their dApp. Or if you want to use Solana liquidity, you can just, let's say, deploy a Uniswap V2 fork and basically deploy a pool with SPL tokens on Solana, or deploy a pool with from like maybe create like hybrid pairs, like SPL and ERC20 pair, or anything like that. So it brings up a lot of other possibilities for, you know, for DeFi as well. No questions? Maybe I have to do my homework better. Maybe no one didn't understand anything, yeah? Yeah, it's pretty new, and it's really, initially it's hard to grasp your head around, you know, it's not layer 2, it's not layer 1, then what it is, you know. But I think that you know, this actually, this is the most, I would say, self-explanatory diagram. But yeah, if you're not familiar also with Solana, and it can be. Yeah, that's true as well. Open my code, yes. You want the last 2 lines of the deployment script?
No, smart contract.
Yes.
And was 2 lines from
Those lines?
it's from Solana virtual machine, ETHGlobal.
So this is the SPL token program. So these are precompiles that Neon built. As Ethereum have precompiles, Neon built precompiled contracts that can basically interact with the Solana programs. And those Solana programs are the SPL token program. As you can see, they have a different interface, and the Metaplex. So SPL token program is basically a program, a centralized registry that can transfer, mint, burn tokens, and Metaplex is for metadata. Yeah, we can talk later because my time is over. So yeah, thank you very much, guys.
Hello, hello. All right, hey everybody, thanks for coming. Let me start my slides. All right. Hi everybody, my name is Eric Nakagawa. I'm from the Celo blockchain, Celo Foundation, sorry. And I help to lead the developer relations team. So excited to be here at our 3rd ETHGlobal hackathon. First, let's talk a little bit about Celo in case you don't know. How many people don't know about Celo right now? How many have never heard of it? 1, 2, 3. Okay, cool. Celo is a project that started a couple years back, and we really want to talk today about helping build dApps for real-world to solve real-world problems. I'm here with the team, myself, Anna, Daniel. We are at the very bright yellow booth in the main stage area. So today I'm going to talk about what Celo is, what's the future for the project, jump straight into bounties because a lot of people want to know what those bounties are. I'm going to show a new project. Very excited to talk about this project, and then go into a little bit more detail on the additional bounties. If you have any questions, I will try to speed through these to answer questions, but if I don't get to that, come see us. First, again, what is Celo? We look at Celo as a place to build with purpose, and we want to build for all, and what we mean by that is truly, just like everybody here, trying to build for the entire world. The difference with Celo is we started several years back, launched the token in a carbon neutral manner back before it was popular, but now everybody's doing it, and we're very happy to hear that. We were launched back on Earth Day, and there have been several projects that have launched on Celo involving things like UBI. This is where everybody gets a little bit of some tokens every single day. They come in and claim it. Projects running that right now on Celo are called Impact Market and Good Dollar. There's also the concept of capital-backed currencies, so people locking up parts of a forest, things like that. A lot of this stuff has been built on Celo, and if you're looking to build a company that touches these things, it's a great place to get started. Some of the features, Celo is an L1. We recently had a proposal on the forum to convert to an L2, and what that means, it's very complicated, but really making that change makes a lot of sense considering when Celo launched, there wasn't, Ethereum was still proof of work. When Celo launched, it's proof of stake, and it's been EVM compatible, but it would be great to come back home to the Ethereum community. A lot of things that were built also were around mobile first. So when Celo first launched, one of the pitches was sort of like a crypto Venmo. And I think we've evolved past that point where everybody has a mobile device, everybody's using all sorts of mobile wallets. And so the Celo team also built some technology around phone number mapping. So one of the great features that I like about building on Celo is I may not know your wallet, but if I know your phone number, I can, in many cases, escrow some funds, or I can send it to a phone number to be transferred to you at some point when you connect a phone number. Other features to think about: quick finality, can do high throughput, but everybody says that. I think we can handle quite a large bit, and I'll share this near the middle part of my presentation. You can also pay with your transaction fees in stablecoins. So if you have, let's say you are sending some tokens to a phone number and you send them a stablecoin like CUSD, they can pay for gas with that CUSD, not require the Celo-based token. So it's a lot of good things for, again, helping people get started. Like many projects, decentralized, community governed, we actually have a hard fork happening on, I'll talk about this in a little bit, happening in a couple days, and it's gonna make every transaction fully carbon negative. So very excited about that kind of stuff. And if you're interested in more of these things, feel free to take a look at Celo.org. So yeah, we're looking to talk about an L1. Changing from L1 to L2 is a very big leap. But again, the time is right. I think the examples I made around phone numbers, escrowing, and all that's great. Ultralight clients also a really big opportunity, and with the shift to L2. A lot of this needs to be discussed in the community, and if you're a part of it, you're welcome to share your opinions. Recently, the Polygon team posted their proposal, Polygon ZK, just to be specific, posted their proposal in the forum, sharing their thoughts on how a Celo L2 could transpire, and it's actually pretty exciting to see more people getting involved. So a little bit more, why would you build on the project? Lots of people using it, lots of wallets. There are lots of organizations driving, keeping the project kind of focused on the core values. I had mentioned things like carbon offsets. We can go a little bit more detailed there. And then there's tons of projects, lots of transactions. There is a very large ecosystem of people building. I would say we need a little yellow circle there for ETHGlobal New York in case any of you are building on Celo this hackathon, but excited to see the community grow. Lots of different projects building on Celo. Some of these are projects that we've either partnered with or working with that you may know. And there's also a lot of businesses that have been, that partner with Celo to reach as many people as possible. So very excited about that. In terms of ecosystem and refi, regenerative finance, a lot of the development that people have done have tried to bring on things like, trying to bring carbon offsets in, trying to bring regenerative finance in. And if you're interested in this path, let's talk. One project is called Climate Collective, which is a help a funding mechanism to help people who are, or projects that are building in that space raise the funding and capital that they need to grow a team. As I mentioned earlier, Ultra Green is our upcoming hard fork. There's this project called Ultrasound Money. Everybody's inspired by other projects, but we launched ultragreen.money, and that keeps track of how much of the offsets. And on Tuesday, the actual switch goes on, and every transaction from that point on will be offsetting through either Toucan or Carbon Path. So very excited about these things, and again, something to think about. One of the interesting things with this change is there is actually an 80% of the gas is going to be burnt, and then 20% is going to be put into offsets. So it's like, I'm no economist, but a deflationary model is very intriguing for many reasons. And I think having the carbon offsets as a part of it will do really, really well, especially with some of the new launches that just have come up. If you're here, you're a developer, you're a product person, marketing, coming up with ideas, and you want to get your idea out there, there's a lot of partners you can be using to launch your project. We have Infura, Lava, QuickNode, and then if there's projects that you want to utilize, take a look at Impact Market, Good Dollar. There's also cross-chain messaging, so Hyperlane, shout out to them. They also have a bounty in case you are trying to stack. And I don't know if any of the other cross-chain folks are here. There's also Chainlink live on Celo and a couple other oracles depending on what features that you need. In terms of stablecoins, you can utilize CUSD, Euro, Real, and if you're looking for DeFi, we have Uniswap and several other SushiSwap, so several other options. In terms of wallets, there is the Valora, which was built by some teams that helped to build the protocol and then launch the wallet. There's MetaMask, of course. You just add it into your browser, your wallet, very easy. If you're looking for an Explorer as you're building, Etherscan's on Celo, but it's called CeloScan. So take a look at CeloScan or the native explorer.celo.org, which is built on Block Scout. So running into some of the bounties, which I think most of the time should be spent on, we're going to be offering 3 top prizes. We're looking for the best projects that align a lot with what I showed earlier. So if your ideas are kind of there and you want to nudge it a little bit, this is a great chance for you to win a potential prize. And then we're also adding another bounty on top of this, which is around building for real-world use cases. And I'm going to showcase MiniPay in a second. If you're also looking at building for account abstraction, on testnet we have Third Web has launched and deployed their SDKs for testnet, so happy to help you folks there. So quickly, I want to talk about MiniPay. It's a really exciting project launched by Opera. And if you're building for a real-world example, this is a bounty that you should sign up for. I'm going to play a quick video. This was announced just last week, so super exciting stuff. Anyway, there's some audio if y'all can play it. Cool. How many of the people here have heard of Opera browser? Very cool. So the great thing about the Opera mini browser is actually a lot of traction in Africa. So large number of users in Africa. I'm trying to skip this. Sorry. So let's run through some of these benefits. So it's super simple wallet built on Android. I got an Android phone right here. They're rolling out to users right now, and it's primarily focused on payments. And so I don't know, when I was getting prepared for my slides, I was thinking, how do I get people excited about this huge opportunity for building for several million people about to be on in this wallet? And if that gets you excited, come chat with us. But I hopefully don't need to connect all the dots for you. There's a lot of really good opportunity. The wallet is self-custody. Transaction fees are very low. As you see here, NGN is Nigerian currency that they're using for folks who are in Nigeria. And then they also provide those folks access to stablecoins, so it can be helpful for people that are trying to, decide what to do with their money. They also do Opera Team, not us. This is not Celo Foundation. This is Celo ecosystem. This is the Opera Team. also provides some free mobile data, which is very helpful for folks who, in some regions, depending on where you live or where you're from, it can be very expensive to do to visit lots of websites or heavy websites. So they help to subsidize that. There's also mobile notifications, and so as you're building for your application, think about like, what would I want to do to push alert to, you know, I don't know, 20,000 of my DApp users. Think that way, and you have a really, really powerful opportunity. So that's the project. It's called MiniPay. You can actually download the beta from the App Store right now. And when we're looking for projects, ideas that you folks may have that fall into these categories, if they do, I think you have a strong chance of winning a bounty. Projects like personal finance, stablecoin yield. I am not an accountant or lawyer, so you need to do your own homework there. Merchants, you know, B2B, or just using things like, if you had a very simple user interface that had like a couple buttons, I don't know, let's say one or two, what could you get people to do to help them try out your DeFi protocol? And finally, or a little bit more detail, how about a gift card idea? A Grab app, you know, something that kind of puts everything all in one place. Someone's gonna build it, it could be you. It could be payment control for families, so I've got kids, so maybe I want them to do, maybe they wanna buy something, but I'm like, you know, I would give you a loan, you have to pay me back. I'm that kind of dad, I guess. And then what about payment splitting amongst friends? Microwork is a very big opportunity for folks to do things. It could be, you know, virtual work. It could be real, you know, in-person, real-life work. Keeping track of things around assets or expense approvals and things like that. You know, some of these things may seem more businessy, but there's a very big opportunity again because of the size of people that are coming in. So one project I came up with, again, I didn't talk to the lawyers, so don't get mad at me. But I built this project, and I'm just putting it up online. It's built off of our very simple to build DApp framework called Cello Composer. And it's really simple. The idea is people can just play, put their name in, a little bit of money is set aside, and then at some point in the future, using a provably or verifiably provable randomization function, they could win. So I'm gonna quickly switch to that just to show this. Let's see. First off, let me show you MiniPay. So this is my wallet, and here's my, obviously I've been working on it. Here's my DApp, super simple. It's a very simple like WAGMI wrapper, so it's not that hard. I just have the concept of allowing people to play the game within, and if you want access to this is a beta feature. So in the discovery page, there's a test dev section. So I'm going to be testing this today for a live demo because that's always exciting. So I'm going to run both of the projects at the same place, and the concept is the way I want this to work is people from their phone, I need to, of course, improve the user interface here, but I want them to just be able to tap and play. So I'm gonna connect my wallet here. Very, very straightforward. I'll chip in a bit. And this should update to, I don't know, 40 something, 41. 0.41 Cello, that's the prize. And then in a perfect world, this will update, but maybe it won't today. This project is meant to be just an example of Cello Composer. Cello Composer is a great way to get started really quickly, got hard hat integrated. It's actually a fork of Scaffold, but built for Cello and added a bunch of features around mobile development. Oh my God, updated. So this is a quick project I want to show you folks, and I will show this is a link to the project. I'll show a link to the project in case you folks want to actually check it out. Oh, here it is. So super easy. Come see me if you actually want to play with it. And if you're interested in actually building for MiniPay, getting started on the project, thank you. If you're interested in building for the project, this is the one to scan. Oh, so here's some of the notes. So yeah, one of the things is with MiniPay, you want to hide your Connect wallet. Yeah, oh my, what about all the other wallets, right? Yeah, just imagine if you got rid of that, how much easier it would be if you just started with your wallet. So that's some of the simple things, and it's not that hard to do some checks. If you're interested in MiniPay, scan this. You'll get invited to a WhatsApp group, and then I'll onboard you folks very quickly into the building for MiniPay. And I actually think if this hackathon isn't the time you build for it, this is a great opportunity, but even if you build a small thing, imagine if you could deploy it to several million users very, very soon. Celo Composer, you can go to our docs.celo.org. Here's another link just to Celo Composer itself. I will talk briefly, I'm going to run through these. You can find everything on docs.celo.org, just go Celo Composer. But if you want to build for account abstraction, again, think about if you had access to millions of folks all over the world and you wanted to build something that made it easy to onboard, account abstraction makes a lot of sense. We've worked with ThirdWeb to support their SDKs. I won't run through all these just because I'm running out of time. But quite easy to add in just jumping straight to here, quite easy to add in account abstraction with Celo Composer again. It's just like Scaffold, but updated for Celo, for the Celo community. And if there's other projects that are available on the Celo network that you folks may be interested in using, this is our third hackathon we've been at, so we know that you folks are going to try to select every single box. Here's some of our friends, and please look at their work. For the bounties, how are we going to judge it? If you're building for MiniPay and you have access to that, and you can put your app inside that and show it to us, check for me. If you have AA working on Alpha-Horus testnet, it'll work. I think that'll count. You get extra points if you run on MiniPay. Not every feature is available, so it's still beta. And then need to see your contract deployed in Alpha-Horus, follows all the rest of the ETHGlobal rules, and just come demo it to our section. If you need tokens, this is our testnet address for the faucet. If you need mainnet tokens, come see me, Anna, or Daniel, and we'll give you a little bit to get started because exchanges take a long time. So that's it from me. My name is Eric. Excited to see you folks build on Celo, and thank you.
Hi, everyone. Can you hear me? Okay, I'll get right to it. My name is Ben Weinberg. I'm a developer advocate for the Axelar team. I'm from Toronto, Canada. Any Canadians here? Nice. Oh, nice. Good numbers. Okay, so agenda for today, briefly. We're going to go over the need for interchain, how we got here, why this matters, the problem with pairwise bridges as they've existed over the past few years, an overview of the Axelar network and the advantages which it brings, and then we're going to get into general message passing, otherwise known as GMP. This will hopefully be interesting for you guys. This is what our bounty is on, is best use of GMP. We're going to go through a code example of it, and then we're going to end off with Axelar in the wild and some fun stats. So a bit about myself. I got into the blockchain space in late 2017, and I'm sure many of you had the same experience. For me, when I was trying to get in, I would go to many meetups. That was my thing. I tried to meet as many people as I could, make friends with as many people. And what I noticed is that you go to these events, you don't know anyone, and everyone seems to know a lot more than you, and everyone is extremely opinionated. And many people at the time were trying to promote certain projects which they were involved in. So there was, of course, Ethereum, but there were also projects that people were kind of promoting as like the Ethereum killers. There was Neo, which was branded as like the Chinese Ethereum. There's IOTA, Tron, EOS, which was branded as like Ethereum on steroids because it was faster and cheaper. And this mentality that people had at the time was that of chain maximalism, this idea that there will be one blockchain to rule them all and the rest will kind of die. And I think it's safe to say, looking back now, that what we've learned is chain maximalism is wrong. This never actually happened. Instead, what we saw was the rise of more and more blockchains. And if I could find my mouse here, this is a brief screen recording I have from a website called Chainlist. And what Chainlist does is it shows you the list of many of the blockchains that exist today. I say many, not all, because it's impossible to actually know how many blockchains exist today. What I'm trying to show you here is that you can see just on Chainlist, there's hundreds, if not thousands of blockchains that exist today. And for our space to be successful, we need to find a way to connect them. And this question of interoperability, if I could get out of this. This idea of blockchain interoperability is nothing new. We've known for years now we need to have interoperability for the Web3 space to be successful. But what we saw was the rise of pairwise bridges, which were using like wrapped assets and multi-sig to handle actual transactions between the chains. And the problem with multi-sig contracts as bridges is that they were extremely vulnerable to attackers, especially if the keys were compromised. And you can see here some of the more famous headlines I pulled up. There are many more than these, but these are some of the famous headlines of some of the biggest hacks that we've seen. The most famous one probably being the 625 million Ronin bridge hack for all you Axie Infinity players out there. But there's also like the Poly network hack that happened just a few months ago, earlier this summer, who had a 3 of 4 multi-sig key compromised. And more so, this interesting article by Chain Analysis, they estimated that in 2022, 69% of all funds stolen in crypto, it's about $2 billion US that was stolen, was actually attacks on bridges. So let's pause right here. What do we know? We know that the number of blockchains is rising. Interoperability is more important now than ever before, but we as a space can do a bit better in the way we conduct interoperability. And that is where Axelar comes in. So Axelar, at its simplest, is a blockchain that connects blockchains, enabling universal Web3 interoperability. And that's a bit of a mouthful. I don't expect you to take a lot out from that, so let's actually dissect this. We're going to dissect it by looking at the Axelar network. So this is the easiest way to actually see Axelar. It's a hub and spoke model, and I want to focus on the last 3 words from that previous definition I had, universal Web3 interoperability. Why am I focusing on that? That's because if you look at some of the blockchains here, you can just notice it. We have Ethereum, Phantom, Polygon. These are examples of blockchains running the Ethereum virtual machine. We also have projects like Osmosis, Juno, the Cosmos Hub, Region Network. These are projects built on top of the Cosmos SDK that are using Comet BFT consensus. We also have Arbitrum. We also have Linea, Base, though I don't think those two are on this diagram here. In total, we have 49 blockchains right now that are all connected with Axelar. And these are different blockchains with different consensus mechanisms, different virtual machines. We have app chains that are on here. Let me go back to this. So that's its idea of universal Web3 interoperability. And the 2 major improvements which Axelar brings right out of the box are that of scalability improvements and security improvements. So let's talk about scalability first. If you picture pairwise bridges, sorry, I know it's a bit hard to read, but let's imagine we have 3 blockchains. In blue, we have Ethereum, in yellow, we have BNB, and in purple, we have Polygon. Now, to connect each of those 3 blockchains to each other, for 3 chains, we need 6 bridges to connect each blockchain to each blockchain. Say we want to add a 4th, say Avalanche. Just for that 1 extra blockchain, we're now at 9 bridges to connect all these blockchains. And you can imagine, like with what I was showing you guys earlier on Chainlist, where there's like thousands of blockchains that exist, to connect each blockchain to each blockchain, or I don't even know how many bridges to connect each of those. But the point is that number doesn't really scale. And if you contrast that with Axelar, where we have a hub and spoke model, all you need is 1 connection to the Axelar network, and then you're connected to all the other blockchains that are connected with Axelar. And I like to think of this in my mind as like, these pairwise bridges are kind of like train tracks. You can go from point A to point B, and that's it. Whereas with Axelar, it's more like an airport. All you need is a connection to Axelar. You just need 1 airport in your city, and then you can connect to any other city in the world that also has a blockchain. So that's a scalability improvements. If I go back to my second point here, there's also security improvements. And I touched on that a bit, but Axelar is a blockchain of blockchains. So what does that mean? It means that we're built on top of the Cosmos SDK. We currently have 75 live validators. Anyone here in the Cosmos ecosystem might be familiar with some of these validators like Figment, Informal Systems, Pokachu. These are well-known validators who are also validating many other chains in the Cosmos ecosystem as well. And this is a tremendous step up, actually having a blockchain to handle interoperability that compared to just like a multi-sig contract. But now that we've covered the use case and how Axelar is helpful, let's look at what we can do now that we couldn't do before, and that is general message passing. And this is the exciting part, I hope for you guys, because it's what our bounty is on, and its best use case of GMP. So what is GMP, or general message passing? It's this idea that we could actually send a message between one blockchain to another. It's pretty straightforward. And you can see myself on Ethereum. This is a picture of me from my first ever blockchain meetup. I spent way too long looking for it. And this is me here on Avalanche. So on the first message, I'm sending like WAGME, like are we gonna make it in this crazy, amazing space that we're getting ourselves into? And then from Avalanche to Ethereum, I'm sending a message called Safe Mint 5 Bored Apes. And what I'm trying to show you here is that in addition to just sending like kind of silly little hello world messages, you can also actually call functions between one blockchain from another blockchain. And that is true interoperability. It's the idea that we can actually interact with contracts and applications on a different blockchain as easily as if they were on our own blockchain. So a very brief diagram here. I know the text is a bit small, I apologize for that, but a brief diagram of how GMP works. So imagine we have, let's start from the bottom left corner there. We have our amazing hackathon project, and we've deployed that on the Avalanche blockchain. On the right, we have also deployed that application on the Polygon blockchain, and we want to send an ERC20 token from Avalanche, from our application there, to our application on Polygon. So the first thing we have to do is interact with something called a gateway contract. A gateway contract is a contract which Axelar has deployed on every single blockchain that it interacts with. So the gateway contract exposes several different functions, including call contract with token. So step one, you have your dApp. Your dApp does some amazing idea. You're going to import the gateway contract, and from the gateway contract, you're going to call this italicized call contract with token. That jumpstarts a process through the gateway contract, which emits an event. The event is then picked up by the Axelar network. The Axelar network member is a blockchain with 75 validators. Those validators come to consensus about the message that was sent. If they're all on board, we're all happy, they send a message to the gateway contract on Polygon, on the destination chain, that the message was approved. And then via something called a relayer, the gateway contract triggers step 4, execute with token. This execute with token is a function which you're going to define yourself in your contract, and you can do whatever logic you'd like with it, with the message that's coming in. You see the bytes32 payload. And we're going to go through a quick code example so you can see that in action. But one more time, high level, your application is deployed on 2 blockchains. You call the call contract with token from the gateway contract. Under the hood, gateway emits an event picked up by the Axelar network. Axelar network lets the other gateway on the destination chain know that, hey, we're good. Then the gateway calls the execute with token function via a relayer. So let's see this in action. And sorry, I know it's a lot, but trying to get through a lot in a little bit of time. So for time's sake, I'm not going to write out this code. You'll see how we're going to do it. But what we're doing here is we're trying to implement the previous example, which is to send an ERC20 token from Avalanche, from the source chain, to Polygon, our destination chain. So first thing we do is import our ERC20 interface from OpenZeppelin, pretty standard. We then import the Axelar executable, which I will get back to in a bit. Sorry, this is small. Let me make it bigger. This is as big as it goes. Are we happy? Can we see this? OK. Next thing we do is import the Axelar executable, which I'll get back to. Then we import the Axelar gateway contract. Is this familiar to anyone, Axelar gateway? That is, remember this guy, the gateway contract, which is going to expose the functions that we need to interact with. So we import the interface for that. We then import the interface for the gas service. This is the other very important contract, which I conveniently left out of that diagram. So let's think about it. If we want to send a transaction from Avalanche to Polygon, we're going to need 3 different tokens. 1, AVAX for the Avalanche blockchain. 2, AXL for the Axelar blockchain. Remember, Axelar, which is facilitating this, is itself a blockchain. And then 3, Matic, that is the token of the destination chain, Polygon. Though I think they're changing the name of that. And the problem is, like, I don't want to hold 3 tokens every single time I want to send a transaction. I don't think you guys do either. So the gas service does it. It extracts that difficulty. We can just, via the gas service, tell our contract, like, hey, we need funds for the Matic, for the Polygon blockchain. We're sending it from the Avalanche blockchain. And I am the person sending this transaction. So now all what you need is the token of the source chain. If you're sending from Avalanche to Polygon, you just need AVAX and you're good to go. And the gas service will handle the rest. It'll handle the Matic and the AXL token. So you don't need to hold all 3. That is what the gas service does. If I go to step 2 here, if I could find it, the first thing we do here is simply in our constructor, we pass in the address of the gateway and the address of the gas service. Remember, every blockchain which Axelar is on has a gateway and a gas service. If I go to step 3, we define our first function which we're going to be using here. This is not a specific name, send to many. I just picked this. You can call it whatever function you want. And send to many, when you call this function, is going to jumpstart this interchain transaction. It's going to be the function that you call to send an ERC20 token from chain A to chain B. And it takes 5 parameters: the destination chain, like, hey, which blockchain are you going to? Destination contract address, which is this contract itself, which will be deployed on both blockchains. The destination addresses, which I will come back to. And then just the symbol and the amount of the ERC20 token that we're passing in. So if I go to step 4, we have some pretty simple functionality here. First, we require, say, like, hey, make sure we pass in some gas, if not, revert. Then we grab the address of the ERC20 token that we're sending. We can do that by just passing in the symbol of the token to the gateway. We then have some standard ERC20 stuff. We transfer the tokens from me to this contract. We then approve the gateway to be able to handle our tokens. Then we encode our third parameter, our destination addresses, which is the parameter I promised I'd come back to. Basically, if you think about it, all we're doing here is sending an ERC20 token from one chain to another. But what's exciting, what I really wanted to show you guys for the bounty, is general message passing. That's what this is all about. So what this third parameter is our message that we're going to be passing along with our token from one blockchain to the other blockchain. And to pass that message, we actually have to encode it into bytes. And that's what we're doing here. If I go to step 5, I now interact with our gas service and our gateway contract. And for time's sake, I'm not going to go through all this, but basically what we're doing is we're telling the gas service, like, hey, call this super long function, pay native gas for contract call with token. And we're telling the gas service, like, hey, we're going to need funds for the Polygon blockchain as well. We then call our gateway contract here on line 61. This is the call contract with token function, which, if you can recall, is the function that we had defined here in our diagram, which was being exposed to us from the gateway. So in our gateway contract, we say, like, hey, we want to pass in the destination chain, like Polygon. We want to pass in the destination contract address, the encoded recipient addresses, so like our actual message, which is coming, and then our symbol and our token amount. And once we call this function, we are going to have kicked off our interchain transaction. So once I call this and all this logic gets executed, our transaction will now be leaving the Avalanche source chain and going to the Axelar network, which is great. But if you recall the diagram, we also need to do something on our destination chain. So the transaction goes to Axelar and then comes out the other side on Polygon, but like, what do we do there? So for that, we have our final function, which is execute with token. And now this function is going to be triggered on Polygon automatically, and it's going to handle some logic with our message that gets passed. And this is our final step here. We're going to be taking our payload. Note it's the third parameter here, which is our message that was passed, our list of addresses. And then on line 90, we're going to take our amount of tokens that was sent, because remember, we're sending an ERC20 token and a message. So let's say we send 6 USDC or AUSDC, and we divide it by how many addresses we've sent. And that is the amount that we're going to send to each address, which is really, really powerful, because not only are we sending the token, but because we're sending a message with it as well, we can compute some logic, in this case, very simple logic, but logic nonetheless that we're going to be doing on our destination chain after our transaction is sent. And I executed this earlier today. I figured I'd be short on time. But it's all done through the Hard Hat CLI, so I'm not going to go through this. But what I did want to show you guys is this transaction actually going through on the Axelar Scan Block Explorer. So remember, since Axelar is a blockchain, it also has its own blockchain. And you can see here the step-by-step of each step of the transaction process. So you can see step 1, the transaction gets sent on Avalanche, the gas gets paid on Avalanche, the Axelar network confirms the transaction. I can scroll down here for more details. Step 3 is confirmed and approves the transaction. And then the final step, it gets executed on the Polygon Block Explorer. And you can see here, I can actually click right through from the Axelar Scan Block Explorer. Yeah, from the Axelar Scan Block Explorer to the Polygon Scan Block Explorer. And you can see here our logic being executed. We send 6 tokens and then evenly send 2 tokens to each of the recipients. So that is a very high level of Axelar GMP in action. The thing I want to end off with is the more fun stuff, just Axelar in the wild. So this is an application called Squid, which is being used today. It might look familiar to anyone here who's ever used the DEX before. And you can see that what's cool about Squid is that in addition to selecting the token that you want to send, you can also select the blockchain you want to send. So in this case, I'm sending GRT from Ethereum to USDC on Optimism. And this is all in one click. Like really, really powerful stuff. And I want to end off with some stats here. This page might look, oh, I didn't spend that much time on Axelar Scan, so a bit unfamiliar. But this is from the Axelar Scan Block Explorer. You can see just some of the stats about the Axelar network. You can see 66,000 transactions, $3 billion of transaction volume sent. And the really exciting part is that this is just over the last 30 days. I know it's a bit small, but it's a really, really exciting time to be familiarizing yourself with this stuff and using Axelar. Here are some resources for anyone doing the bounty. On the left, I highly recommend. It is a series of YouTube videos we have, just explaining this stuff. And on the right is our GitHub repo of just examples using this stuff. And yeah, thank you very much. My name is Ben Weinberg. Hope to see you guys around.
Hi, everyone.
Hi, Ziad.
Hi. Oh, hello, friends. All right. Today we're here to talk about MetaMask snaps. We have a bunch of bounties for you, so this is very exciting. We also launched snaps about 1 week ago. I'm going to tell you a little bit more about that. But first, about myself. My name is Ziad. I am the developer advocate for MetaMask snaps. You can find me on Twitter, Instagram, all the social media, ZiadMTL. And before we get started, this is a QR code for this presentation. And if you're hacking on one of our bounties for MetaMask snaps, you're going to want to get this presentation because it has all the resources that you're going to need in order to get started hacking with us. Very briefly, let's talk about MetaMask. MetaMask is the most popular self-custodial wallet, 30 million plus users. I'm very proud to work for MetaMask. I have beautiful colleagues, and we're doing some great stuff for Web3. It was released as a browser extension, and it lets browsers connect to Ethereum-compatible blockchains. But not just Ethereum. As of September 12th, MetaMask is now able to do a lot more things thanks to snaps. Snaps are add-ons for MetaMask. They enable the addition of new features to MetaMask, and you can develop those features, anyone, by using our APIs. And we're going to see how to do that in this workshop. You build snaps with TypeScript or JavaScript source code, ideally TypeScript. And your snap, your JavaScript codes runs in a secure sandboxed environment so that you can only do the things that we allow you to do and that the user of MetaMask allows you to do. Once you're done developing your snap, you publish it as an NPM package. Anyone can install it, and they can do a lot of things with it. Like what? Well, yeah, we launched on September 12th. So what can you do with snaps? First, you can add non-EVM chains to MetaMask. That means you can own Bitcoin inside MetaMask, or Dogecoin, or any other coin that you want. You can increase the security of the wallet by providing the user with transaction insights, telling them that a transaction is maybe not safe based on some algorithms that you have or some proprietary information that you have. You can add distributed identity features to the wallet. You can add communication features to the wallet. And there's a whole bunch of other support APIs such as networking, secure storage, custom UI that you can use as a support to build all those features that you're building. And there's a lot more on the way. If you looked at our bounties, which I'm going to present in a moment, you will see that we're already starting to develop more features just as we have launched. So what are some of the things that people are building with snaps? Well, if you go to snaps.metamask.io today, you are going to be able to download and install in your MetaMask browser, in your MetaMask extension, 35 different snaps. The biggest category is interoperability. We have a Cosmos snap, we have a Bitcoin snap, we have a Leap snap, we have all the snaps that you see here, and all those can allow you to manage all these accounts securely from inside MetaMask the same way that you manage your Ethereum. We have transaction insight snaps, which allow you as a developer to add some data inside the MetaMask UI to give more information to the user about a transaction that they're about to make. And we also have notification snaps that allow communication features. So let's talk a little bit about our bounties before we start looking at a demo. For the ETHGlobal New York hackathon, we have two bounties. The first one is prompting you to build a transaction insight snap with a V2 that is so new that it's not yet in our documentation. So this presentation contains a link to a beta documentation that you're going to be able to use in order to hack on our bounties. We also have a bounty for a domain resolution snap. This is a feature that's not even live. You're going to have to use a special developer preview of MetaMask in order to be able to build on that bounty. And you're going to get all the information during this presentation. This is the link to it. You can scan it if you want, or if you scanned the QR code earlier, you will have access to it. And we also created a developer guide for you, especially for this hackathon, so that you can get started easily. All right, so now you're all excited. You've seen all the beautiful features that we can build with snaps. So how do you get started? Well, it's very easy. All you have to do is run one command on your command line. We're going to run it in a minute, and it's going to provide you with a full repository that contains everything and a fully functioning snap that you can start editing right away. So you don't have to start with a blank page. And there's one more thing. You're going to need to get set up with a special version of MetaMask called Flask. It's a developer preview of MetaMask. It looks exactly like MetaMask. It has a different icon so that you can know that it's a different one. And also, don't put any live private keys in there that you care about. It's really meant to be used as a separate extension, ideally in a new browser profile or in a completely different profile. And you can get it on metamask.io/flask. All right. And the rest of this presentation contains a bunch of links for you that will also give you some inspiration, that will give you some more documentation about everything that you can do with snaps. And that being said, now I would like to walk you through what happens when you run that command that we looked at earlier, and what kind of code you get. And we're going to see how you can use that code, how you can debug a snap, and we're going to get started right away. So the command was yarn create. You can also use npm if you like, @metamask/snap, and then the name of your snap. And I was expecting the network to be a little bit slow here, so I've already set up a new snap from scratch that we're going to be using for this presentation. Here it is. And I want to double check how the font size is looking on the screen that you're seeing. It's a little bit small, so I'm going to make it a little bit larger. All right, so once you run that command, you get a full Yarn repository that has 2 packages in it and a bunch of setup files. So very quickly, you get a site package. You don't need to use it. It's a DApp that allows a user to install the snap. You can add some buttons to it that will allow you to interact with your snap as you're building. And the most important package is the snap package. It contains some TypeScript code as well as some commands that you can use as a developer in order to quickly get started building with snaps. And how do you get started building? Very easy. You go on your command line and you run yarn. What? Yarn what? What do you think? Start. Yeah, simple, easy. Just yarn start. And what is this command going to do? It's going to run 2 processes in parallel. The first one is a development server that is going to be constantly looking at your snap code and rebuilding it on the fly as you're changing your code. And the second one is going to run the site package, which is a simple DApp that has a few buttons that allow you to install the snap, interact with it, and get started. It's built using React. And it's very easy to get started with. We're not really going to be looking at it today. It's basically a React site with some buttons that are interacting with the snap. And once the development server has executed, you can just go in your browser. You go to localhost 8000. And you get presented with a very simple DApp that allows you to connect with the snap. Now, because I've already connected with this snap before, the button says reconnect here. And this is very important. As a developer, as you're making changes to your snap, the snap gets recompiled immediately. Your TypeScript code gets recompiled immediately. But if you want to see those changes, you have to click this reconnect button so that the snap will get reinstalled with all those latest changes. So this is what happens when you do that. Ask you for your password. I hope I remember my password. All right. And then you get a dialog that asks you to install a snap. This is exactly what your users will see once they install your snap, once they interact with your snap. And we can see here that in addition to giving you some information about the source of the snap, the name of it, there's also a very important section here which lists all the different permissions that a snap is requesting. A few moments ago, I mentioned that a snap runs in a sandboxed environment. So even though you're writing TypeScript, JavaScript, and it's seemingly running in a browser, your snap code doesn't have access to anything. Cannot fetch data from the network. It can't do anything. And through this permission system, which you set up through a manifest file, you can ask the user to do things. For example, in this case, the snap that you get as a template when you get started is asking for 2 permissions. It's asking to be able to communicate with websites, which means that your snap is going to be able to provide an API, an RPC API that websites and other snaps will be able to use. And it's asking to display dialog windows using this custom UI feature that we're going to look at in a minute. So if I say install, the snap is going to be installed. And then where am I going to see this? In my MetaMask, if I go in my settings menu, there's an option that you might not have seen before. It's now live in the main extension. It used to be only in this MetaMask Flask version, called Snaps, right here. And under here, you will see all the snaps that you've installed. And if you go in there, you will see all the dApps, all the websites that are connected with your snaps, all the permissions, and the ability to remove the snap if you want to. In addition to this, the dApp contains a send message button. This is a button that is going to be calling a function from your browser, from this web page, using the Ethereum provider. And this is going to call the Snaps RPC API in the example that we give you. And it's just going to show a demo of the custom UI features that we have in MetaMask snaps. So when I clicked on this button, the dApp securely communicated with the snap through its RPC API. And inside the snap code, we're using the custom UI feature in order to bring up this dialog. And whether I click approve or reject is not going to have any effect in this dApp, but the snap will be able to have access to the response from this dialog. It will see whether the user has rejected or approved. So if you're building a Bitcoin snap, for example, and the user is about to make a transaction, you're going to want to show them a confirmation. You're going to say, for example, hey, you're about to spend 1 BTC and you're going to send it to this address, and then they'll have the ability to approve or reject it. And based on that, you can continue the logic and the asynchronous logic inside your code and decide what you want to do with that. So right now, it doesn't matter whether I click approve or reject. We don't have a lot of time, so I want to show a little bit the code that's driving what we just looked at. So inside the snap package, the source directory contains only one code file, index.ts, and this is the only file that you need. If you start building a more complex snap, you're going to have modules, you're going to have all sorts of files in there, but this index.ts is going to export some functions that are going to allow MetaMask to interact with your snap. The one that we're using here is called onRPCRequest. This function is detected by MetaMask and is called every time that a dApp makes an RPC request to your snap. Very simple. And how does a dApp make an RPC request to your snap? Well, it has to have the permission for it. Our snap asks for a permission to be communicated with by websites. And these permissions are located in the snap.manifest.json file, which is at the root of the snap directory. As you see, it's not in SRC. It's right at the root here. And it contains a bunch of metadata about your snap. And the permissions are inside this field called initial permissions. So this snap that you're getting provided with asks for 2 permissions, displaying dialogues, and the ability to expose an RPC API that only dApps can communicate with in this case. Snaps are not allowed to communicate with this snap because this is set to false. Thank you. And so what's in there? Well, in this case, it's very simple. It's a function that receives the origin of the RPC request, as well as the request object itself, the JSON RPC request. And in this case, we're doing a very simple switch statement. If the method that comes back is hello, we are then using the snap global variable to request a dialog to be printed on the screen. This is the dialog that we saw earlier. It's a confirmation dialog. You can set up the content using these panels, these text elements. We have a copyable field and a lot more coming on the way. And this is how you set up your snap. And in this case, we're only returning that value to the dApp that has called us. So this is not very useful in this case. But with the few minutes that I have left, I want to show you something very important that you're going to need as you're starting to develop and debug with your snap. What's the most common feature that we use for debugging as developers? Console log. Yeah, console log. It's everywhere. I even have a t-shirt with it. So you would think that if you were using a console log inside your snap, that the log would appear in your developer tools right here, but it doesn't. And so with the few minutes that we have left, I just want to show you how to debug your snap so that you can more easily get started as you're working on our bounties. So I'm just going to change this code a little bit. I'm going to assign the result of this dialog request to a variable. And yeah, the function is not async. And then I'm just going to console log that. Right here. And as I do this, if I switch back to my terminal, you will see that those changes are being recompiled immediately using the snaps bundler. And if I go back to the dApp, this is where I have to reconnect to the snap. Those changes that were just built are not going to be detected by MetaMask right away. So I'm going to reconnect. The permissions haven't changed because I haven't touched the manifest file. And once the installation is complete, now I have the new snap available to me. So how do I debug it? I just go to Manage Extension by right-clicking on the MetaMask Flask icon in my extensions. And you want to make sure that developer, I don't know if I can zoom in on this. Yeah, you want to make sure that developer mode is on. If developer mode is not on, you're not going to see the debugging option. So make sure developer mode is on, and then you're going to get an inspect views field here with background.html. Thank you. And if you click there, it's going to open another developer tools. And this one is for the MetaMask extension. So there's going to be a whole bunch of things popping up in there about MetaMask itself. And as you interact with the snap, for example, if I click approve here, then I'm going to get an error that says method not found. Well, let's debug that. I don't know what happened, but I did get my console log here, by the way, that says dialog result true. And I think the reason why it says method not found is because I haven't returned anything here. So I'm going to just say return true. And I recompile the snap. And that's going to take us towards the end of this presentation. So this time, get the dialog, I click reject, everything works. And then I get my console log here that says dialog result false. This is about all the time we have. So I wish I could have done a full workshop, but what I'm going to do instead is if you connect to me on social networks, on Twitter specifically, I'm going to be announcing in about a week, I'm going to be coding that live on Twitch. We're going to do a full session of coding a snap from start to finish. I know it's not going to help you with this current hackathon, but we have a MetaMask booth. If you go all the way to the end and all the way to the corner, you can't miss it. It's right in the corner. It's a big white booth. And I'm going to be there most of the time to answer all your snaps questions, to help you with your snap, whether it's validating your use case or debugging it with you. And I think I'm out of time. So I want to thank you very much for joining us today. I hope you're going to be successful developing your snaps. And I'll see you at the conference.
Can you change it, or do I need to press buttons?
Oh, it's...
So, hello, ETHGlobal. We are Sinu and Hendrik from the TLS Notary team, which is part of the privacy and scaling solutions from the Ethereum Foundation. So first I'm going to introduce you TLS Notary, show you why we build it, how it works, and then Sinu will give a demo of how you can use it for your projects. So first, why do we build TLS Notary? So I assume everybody knows what TLS is, the Transport Layer Security. So it allows for a secure way for Alice to get data from a web server. And TLS guarantees that the data indeed originates from the origin and that the data was not tampered with, so that the data is authentic. But what TLS does not help you with is make that data portable so you can share it with somebody else. And so that's where TLS Notary steps in. So TLS Notary gives you a way to make your data portable and also use your data with a third party. So this is more or less what TLS Notary looks like. So the magic sauce is that we introduce multi-party computation. So before we go move further, no confusion here. So it's not man in the middle. So it's not that the verifier Bob gets in the middle. No, instead, multi-party computation, Alice and Bob have to work together. They each have a key share to communicate with the server. That way, Bob knows that Alice follows the protocol and cannot cheat about the content of the data. And at the same time, Alice knows that Bob only sees encrypted information, so that Alice is in full control of what she shares with Bob in a later state. So this is also something very important for TLS Notary, is privacy. So TLS Notary also supports selective disclosure. So Alice can redact parts from the data before sharing the plaintext data with Bob. And this can also be further enhanced with zero-knowledge tools, so that you don't that you also can share information about the redacted parts in a way that Bob only knows statements about it instead of seeing the actual text. The concept of checking the TLS communication can also be generalized, so that you can get generic notaries that check that the data is authentic, and in that way Bob only checks the content of the data, but in this scenario, of course, Bob has to trust the notary before he accepts that the data is trustworthy. So that was very quickly, but now the more interesting part, how you can use it for your project.
Hi everyone, I'm just going to give a relatively short demo on how to use our project to query a server for some private information and generate a cryptographic proof that can be used to selectively disclose a Discord DM to someone else without revealing the prover's authentication token when doing so. So first, let's hop over to our repo here. So this example is in our repo, and you can follow along if you want to. So it's under TLSN, examples, Discord, and we have a README here for what's going to happen. So yeah, I'm a prover. I want to prove to someone that I've received a private DM. I don't want to use OAuth. I don't want the server's help. But nonetheless, I want to be able to selectively disclose that I've received a DM to someone else. So here's the Discord web app. I'm logged in already, and I received a message from myself here, Hi ETHGlobal New York. So what I'm going to do to just get the access token here is refresh, and I'm going to go into the browser, and I'm going to find an API request that contains my authentication token. And you could definitely hijack this account right now if you wanted to once you see this, but please don't do that. So here's my authorization token. So this is what the browser sends along with my request to the Discord server. I'm just going to grab that. I'm going to pull it out into my example here. So we just have an environment variable file here. I've already got my access token loaded into it. And one more thing that I'm going to need here is the channel ID, or like the conversation relevant to this message. So I'm trying to prove this message here from me, and the conversation ID is just up here in the URL. So I'm going to generate a cryptographic proof that I received this message, and I'm going to show it to someone else. So to do this, we need two different things. So there's going to be the prover, and there's going to be a notary. So the notary is going to essentially help me do this. So yeah, I will just fire that up over here. So I just started up a notary server. It's kind of generic. It just sits there listening for requests. And on the left side here I'm just going to clear this out. The left side here will be the prover flow. So before I run this, I'm just going to quickly walk through what this actually looks like and how you could modify this to do something more interesting than disclosing a DM message. Essentially, you can query anything on the internet and generate a cryptographic proof of its authenticity and disclose like portions of it to a verifier. So any web server that supports TLS and any data that you can think of. So yeah, I'm just gonna use our prover library here. So yeah, we're gonna connect to Discord and we're going to connect to the local notary that I have running in that other panel there. And we're just going to use basically just generic Rust tooling, the hyper library, to construct a request and send it off to Discord server. But what we've done is you're essentially exposed to like a generic TLS connection. So from like your perspective, you just get this TLS connection, you pass it into the request library, and you can just interact with APIs as you normally would with any other connection. But then afterwards, we're going to finalize it and get a proof. So yeah, I'm going to just set up some generic configuration for the prover here, and it will connect to the notary. They'll perform some MPC-related setup at the beginning. And then after that, we're going to actually connect to the application server, send off the request, and get the response back. So yeah, let's walk through that a little bit here. So here I'm just constructing the request. This is just the API endpoint for Discord's API, and I'm going to query for this specific conversation. And I'm going to pass in like the user agent and the auth token that I just pulled out of the browser. Once I do that, I'm just going to get the response. I'm just going to print it out. And from there, we will finalize, I guess, the process with the notary. And from there, we essentially do a bunch of finalization of MPC behind the scenes for you. And what you get is this kind of succinct proof of the transcript of all the communications with the server. And then once we get that proof, we can selectively disclose portions of it to a verifier. So I'll just run it here. You're not really going to see anything interesting, but hopefully it works. This is a live demo, so I'm querying Discord's API right now. And done. So yeah, I just connected to a notary. You see an error there. Let's just sweep that under the carpet for a second. It did actually successfully complete. So yeah, now it's saved this JSON file here. This is essentially just the notarized session. So this contains all the private data of the session, as well as a signature from the notary. And using all this data, you can construct proofs from it. I will go down to the actual proof generation section of this code. And you can see that we essentially, where's the, here. So we're identifying all of the ranges in like the TLS transcript that actually contained like public data and private data. We need to differentiate between that when it actually commits. So essentially what I've done is just implemented a simple helper function here, but it just looks for the auth token in the TLS transcript and identifies like the ranges in the transcript there. And then we commit to like the surrounding data as well as the auth token itself. And we get like a bunch of different commitment IDs from this. And then later when we actually generate our proof down here, we just say, okay, we want to reveal like the data that corresponds to only the public ranges, and we're going to redact specifically just the auth token from the proof. So yeah, it builds the proof, and that also just got saved down to a JSON file here. It's, once again, just a small JSON file that just contains essentially just the proof itself. And then we have another example here is what does the verification process look like for a proof like this? This is just a simple verifier. It just deserializes the proof from the JSON file, and it verifies it for you. So it's pretty simple. You essentially just need to provide like the notary's public key. So in this situation, we used a notary. So the verifier actually does need to trust the notary that the data is authentic. So we pass in its public key, and it essentially verifies the server certificate, and then it also is going to print out the redacted TLS transcript. So. I'm going to run the verifier, and it's done, and I'll just show you the output here so you get the general gist of what just happened. So this is the entire TLS transcript that occurred with the Discord server. The prover revealed essentially everything, except here you can see that the authorization header in the request, which would allow you to hijack their session if they had this has been redacted out and replaced it with X's. So the verifier here has done a few things. One, they've verified the identity of the server. They checked the server's TLS certificates, so they know that this actually came from Discord server. They verified the notary's pub key, and in this case, they trust the notary so that they know that the data is authentic. And now you can just parse this data out. And I guess your application here could be like a DM verifier, and it would just parse the contents of the server response and say, oh, look, this message was in fact sent to this account at this time, and this is the content of it. So again, you can think of replacing this DM flow with basically any information on the internet. And yeah, that's essentially the demo. I'm glad that it worked for the most part. So yeah, you can go to our GitHub repo. We have a couple other examples. We have a Twitter DM example and just some example code for how to set up a notary and such. And then, yep, that's essentially it. We're also, yeah, our repo, you can find our docs and stuff. And where's the presentation? There we go. Yeah, so tlsnotary.org, you can find us there. And you can also find our docs as well. Great, thank you. Do you have a question?
Yeah. Did you separate the public and private data after the notary sign?
Well, you have to commit to it first. So before the notary gives you the signature, you essentially say, these are the ranges that I'm going to commit to. The notary doesn't see any of the private data, but you still have to identify where it is and then commit to it. Then the notary will sign your commitments, and then you can take those commitments over to a verifier and open specific commitments to the verifier. Yeah. Are there any other questions? Oh. I think I only got 5 more minutes or so. So we do have a prize here, Hackathon. We have 5K. Our project is very early stages, so you're going to be pretty brave and ambitious if you're going to try to use our libraries. But we thought that we'd come here and see if anyone has any cool ideas. You can just hack on it, see what you can do. And yeah, any kind of application, of course, will be super interesting, but any sort of tooling as well. If you want to build anything that just complements or integrates with the protocol generally, that would be extremely helpful as well. And all right, I think I can end it there. Thanks, everyone.
Oh, hey there, guys. Good afternoon. Today, so sorry. I'm gonna be talking about what Cortese is promoting as a layer 2 and how it's gonna help people onboard more developers and how everything comes together in this Linux environment. I guess it's a little bit awkward and strange at first, especially because we're so used to EVM compatibility, solidity, and all that good stuff. But I'm gonna show you guys there's something else out there as well. So today I'm gonna introduce a little bit on how Cortese rollups work. And then I'm gonna show you guys how the interface is and how to program it for it. And by the end, I'm gonna show a few examples of things that have been built using Cortese. So just as an introduction, this is a small example of a smart contract already using Python inside the Cortese ecosystem. And it is here to just incentivize you to pay attention to certain aspects of it. By the end of the presentation, I'm going to go back to it, and I'm going to explain some of the lines that are more important over here. So the overview. Pretty sure you guys are already familiar with the trilemma and what it means for Ethereum and what it means to the security of blockchain systems. But we all know that we need scalability, and we are trying to figure out how to make it work. And here I'm going to show you guys that it is possible to have complex computation and great tooling while developing smart contracts, only if you introduce back again a very important concept that we are forgetting: an operational system. So how does Cortese make it work? Cortese is an application-specific rollup. So it's an optimistic rollup dedicated to a single dApp. That means that you have the flexibility to change parameters and change how validation might happen depending on what it makes sense for your application. But at the same time, it means that you can have it as a layer and solution. So right now, the current system is EVM compatible, meaning you can deploy to any EVM execution environment. So it can be a layer 2, a layer 3, whatever you think it makes sense. And the second part of the solution is the fact that instead of focusing on the EVM itself as an execution environment or WASM or something like that, Cortese focused on bringing RISC-V to the fold. And what we did is create this machine emulator that is deterministic. And because the instruction set of RISC-V is very complete, it means that you can use any OS on top of it. And therefore, we chose to go with Linux, of course. So how does it feel, right? It feels like for all these years, we've been playing with flyers to make things work in the blockchain ecosystem. And when you try to use Cortese, it feels like you have the whole tool set back. So it really improves the experience of developing applications. And this is how it looks like to actually be building your application. It's just a system of Docker containers that builds up to be the Cortese node that you're going to develop for your application, meaning that you can just use any language, use any tooling, any of the things that we are used to have. So if you think it's interesting to have a Postgres database inside, you can have it. If you think it's interesting to have a Redis or to import frameworks such as OpenCV or large language models, we've seen examples doing that. And as long as you can properly build your Docker machine, you're fine. So that's what it means, right? Like it becomes very sexy. You can even import that one-star repo that for some reason you're just so eager to. So to be fair and display a little bit of how it feels, I'm gonna be very generous to the Ethereum network, and let's go with 30 million gas of block size, which is already not ideal. And if we take just the addition opcode, which is the least that does something, you can have about 10 million instructions per block, right? And this is what it takes to put Linux it takes 3.6 million CPU cycles to boot it. So it would never really be feasible, even interesting, to have Linux on top of Ethereum network. It's comparing apples to oranges, right? It does not make sense. They have different goals. And within 13 seconds, just to maintain some comparison, which is the block time on the Ethereum network, on a laptop such as this one, you can have 36 billion instruction cycles run. So that's a lot. That's a lot. Correction, guys. 3.6 billion. And that's how it looks like. That little black dot over there, it's the scale of what Ethereum does in 13 seconds compared to a single laptop running a Cortese node for your application. So the rollups themselves, how the architecture looks. For people who are familiar with rollups, there's nothing new here. It's more for people who are trying to understand what it means to build a dApp using a app chain or application-specific rollup. So here you have a browser representing some kind of UI and interactions of the user. You're still going to be sending transactions to your base layer, represented by Ethereum over here. And this Cortese rollups framework, it really is the node with some other services that make it feasible and convenient to use, such as reading information for an Ethereum chain. But what you're going to be building is this Cortese machine block inside. And we package it already ready to use with a HTTP API that will be convenient to make inputs and outputs to the base layer. And the dApp backend little box is what you're going to be coding. So you can code it in Python, in C#, C. You can code in brainfuck. You can use whatever, really. As long as you can do GET and POST requests to this API, it's going to handle the communication side of things. So it really is a sandbox environment. And as you build it, it can put anything inside. But as long as you remind yourself that it needs to be self-contained, it can run on Cortese. So back to the code I showed you guys in the beginning. So this is a very simple smart contract. It's not smart at all, actually. It's an Echo Python example. What it does is whatever it receives as information, just plain text messages, it replies back using one of the output methods. So if it is a read request, read-only request, just like ETH call, gRPC call, you can recreate this report, they're kind of like logs. And if you have like actual transactions, state-changing transactions, you can create these notices. And notices are kind of like Ethereum events that have a Merkle proof attached to it. So you can go back to the base layer and actually do something about this information. Finally, not represented here, there is the concept of vouchers. And vouchers are transactions that will be able to be executed in the future. So you go on throughout the settlement period, execution period of your rollup, creating these vouchers. After you settle, they become executable because you have Merkle proofs attached to it. So going back here, you can see on lines 18 to 20 that I'm declaring some high-level handlers. These are the basic handlers every Cortese application should have. You can create many more just as routes in an API. And these two high levels are the ones that I was talking about before. One is for read-only requests. The other one is for transactional requests. The read-only, it's really interesting because the node manages snapshots of the machine. So if you try to change anything on the application, it's not going to be saved. The machine continues pristine from the last transactional request. The same is true if you reject the input. So because of the way EVM works, and it's interesting in blockchain systems that you'll be able to handle, let's say, weird corner case scenarios. So you always have the ability to throw in Solidity, right? And reject the input and still maintain the pristine state of your smart contract. Here is the same. After handling a transaction, you can send a reject response for the input, and the machine is going to be reverted back as if it never processed the transaction in the first place. So the idea here is to enable the dApps that we've been developed to be further decentralized, not necessarily needing to rely on off-chain computation or data sources and things like that. Also to have a faster development cycle and more concise and comprehensive by expressing more complex logics, by having the ability to import libraries and frameworks that many people have been building for so long. You have the ability to have extra processing power, so you can think, again, that you can use loops even and things like that. And you can leverage the traditional stacks because sometimes they're just nicer to use. And finally, as you're developing a new project, you gotta know that eventually your project might need new developers. And there's a very small pool of developers on Web3 right now. But it's easier to onboard Web2 developers if you have a framework where they can use the language they already know how to code with. About the POCs. So at ETHGlobal Lisbon, we had this hackathon winner, ChainGPT. This person was concerned about the open source large language models and what the influence large companies can have on them. And she just used a simple example, but like, what if Coca-Cola managed to mess up with the responses of the model, and suddenly you have like 10-year-olds questioning like, what is a healthy drink? And Coca-Cola is like the first response. How do you prove it if it's basically a random in essence, right? Are you gonna do some statistical analysis? How do you prove it replied to your children that kind of response? So she was like, okay, but if you run the inference in such an environment where you have validation process, you can prove that at that exact moment, the response was such. So what she did was she imported the alpaca model inside a Cortese machine and ran an example showcasing the power of it. And the second one is kind of funny. Basically, there is these systems where you can clock in and clock out of factories or government institutions using fingerprint. And in Brazil, people are pretty good at hacking this thing. Between silicone fingers and just bribing the person next to the machine, it's not really reliable at all. So this guy who was just trying to understand how Cortese works thought it was going to be an interesting experiment to create such an application. He used OpenCV inside the machine to do the recognition of the fingerprint itself. And at the same time, he used a machine learning model that he built to check against forgery and spoofing. So with these two models running alongside, people can scan the fingerprints and, I guess, optimally in a more private setting, send this information and be auditable. If you guys want to know a little bit more about other examples, other projects that have been built using Cortese, even games, we have a bunch of games being built with Cortese rollups. You can check rolluplab.io. People are sending their projects there. And also for this hackathon, we have such a distribution of prizes. We are track here. We're going to be throughout the whole weekend helping whoever is trying to build with using Cortese. Finally, pretty soon we're going to be launching a mainnet, a honeypot dApp. The idea here is to showcase the security of the rollup. So the foundation is going to be depositing some amount of money periodically, increasing the amount of value locked, just to ensure, just to give insurance to people that there is something out there with a lot of money value locked, and nobody was able to hack it. So they're actually inviting hackers and security experts, white hats, other hats, to just try and steal this money. I'd say this is the end of this presentation. However, I have one more thing for you guys. So it happened a while back. Some guy was just scrolling on Twitter asking, what if EVM, if EVM in Ethereum is the global computer, why haven't we seen Doom running on it, right? And Eduardo, by the way, is he here? I thought he was here. He came here for a second, guys. You're gonna see him around. He just said, like, fuck it. Took a weekend and he ported Doom to the Cortese machine. So this is actually running right now. You can stop by our booth and play a little bit with it. And the idea here is just showcase that even freaking source code that is like 30 plus years old can be built and compiled and run without major efforts on top of such an execution environment. Now, yes, I'm open for questioning. Any doubts? Okay. Cross-chain messaging?
Yeah.
With? Sorry?
So is there any way to like read the state of the Ethereum L1 or any other chain in this Corsesi version?
So he's asking if there is any way to read the state of networks within the Cortese machine. But more specifically, you're looking for cross-chain stuff, right? Okay, so yes and no. So the rollup itself is attached to some base layer, so you can read the state from there, of course. Mostly, the current state of the SDK is that you just get the messages that are coming towards the rollups. But the idea is to have something like pre-image. We are calling actually the hashing device, where you can have a device inside a Linux machine where you can send it to it any hash related to the base layer and receive as a response the actual data. Because you have a proof for it, it's possible to do a verification game, a dispute game later on. So you can read from the base layer you attach to, but from others, there is no current solution under development. Any others? Guess that's it. I hope to see you guys around. We are here throughout the whole weekend. I'll be happy to help with any questions, any issues you have while trying to compile anything. Thank you, guys.
Hello, everybody. How are you? Good? My name is Germán. I'm Developer Relations at SAFE. Today, I'm going to be talking about developing on the SAFE Core protocol. So, SAFE Core protocol, does anybody know what it is? Can you raise your hand if you have heard of it before? Okay, good there, good there. Awesome. There are so many questions, many new terms and concepts that were introduced in the SAFE Core protocol in the last couple of months. Now I'm going to try to summarize most of them, and you tell me at the end. So first of all, I will be talking about the SAFE Smart account, what it is and how it looks like. Then the SAFE Core protocol, the same, but also how it is connected with the account. And also, I will be sharing some resources that you may find useful for the hackathon if you are hacking with us. So let's start with the SAFE Smart account. The SAFE Smart account is a modular account framework. So it's basically an account with SAFE. It allows many things, execute transactions, sign transactions, etc. But here, primarily, we are going to be sharing how it can be, the functionality can be extended via modules. For example, let's say a recovery module that at some points allows to execute a transaction in the safe that replaces the signers. So if you lose access to the account, you can recover it later. We also have transaction guards. Transaction guards are logic that can be added when the transactions are executed. So they are able to parse the transaction, read the destination, the value, the data, and some other parameters, and act on that. For example, we could have an allow list guard that has a list of addresses, and then if a transaction is executed, this guard would check the destination, and if it's not in the list, for example, the transaction would be reverted. And also, we have fallback handlers that would allow to add new extra functions to the core contracts. So in case there's a standard introduced that is not natively supported in the account, then you could implement the required functions in this fallback handler, plugging it to the account, and then everything would work. So I guess and hope that we all agree that modular smart accounts will fail without three things: interoperability, discovery, and security. Interoperability, because there is a risk of vendor locking, different teams working on different tools and creating a fragmented ecosystem, also duplicating work on the same things on tools that are not compatible. Regarding discovery, there's currently no place to find these smart account extensions like the ones we saw before. So there's a lack of distribution, and it's difficult for users to see what the market has ready for them. And regarding security, we still need to make sure that the funds of the users are secure and there are no risks. So in the last couple of months, the team at SAFE has been working on the SAFE Core protocol that tries to fix these three topics I just mentioned. So let's see what the SAFE Core protocol is. It's still in alpha version 0.1. It's ready for hacking, so you can use it this weekend, but it's not production ready yet, so expect changes and things to break. It's also designed to be account agnostic, but for now we are focusing on SAFE account version 1.x, just to make the development processes faster and to gather some feedback. It's also open source, and right now is the best time for you to provide feedback on the protocol if you want to give us some ideas, share your pain points, etc. Now we are still building on it, so it's the best time for that. So this is what we had for the Safe Smart account, right? The account in the middle, and then different components that are enabled into the account directly. So the owners of the account need to enable and disable these one by one. What the Safe Core protocol introduces is a manager. This manager would be another smart contract that will be placed in the middle of the account and all these modules. It will be orchestrating all the flows as well. This manager, like the Safe Protocol manager, will also have access to some registries. We have an implementation for the Safe Protocol manager and a Safe Protocol registry. And this registry will be owned by maybe a person, maybe a company, maybe a DAO, ideally. And the owners of registries will be in charge of adding different modules there and setting the requirements for these additions. For example, as an owner of a registry, I can say, okay, I will list, in order to list some modules there, they must be audited and blah, 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 different criteria that they need to meet. And finally, we have the modules. Modules can be of different types. And now there will be a relation between these new ones and the ones we saw before that were enabling the account directly. So first of all, we have plugins, like the recovery plugin. If you remember, there was a recovery module that was connected to the account directly. And here, as a plugin, the functionality of this recovery plugin would be the same, but plugins need to implement an interface that allows them to work with the manager. So not directly with the account, but they will be they should be listed in a registry, and then the manager will check that they are in the registry, and they will connect it to the account. Same happens for hooks. Hooks are very similar to the transaction guards we have. So for example, we can have an allow list hook. They will also work with the manager and can be added to registries. We also have the function handlers that will work very similarly as the fallback handler that you saw before. We also have signature validators, and in the future, many more kind of modules can exist. So let's see now, just focusing on a plugin, how to add a plugin to a registry, how to enable a plugin into an account, and how to execute a transaction via a plugin. So let's start with adding the plugin to a registry. We see the 4 main components here, and to add a plugin in the registry, it is the owner of the registry, the one who should call a method add module to the registry. And that's it. It's more bureaucratic for the owner of the plugin because they need to meet the requirements the owner of the registry defines, but technically it's as simple as this. Once a plugin is added to a registry, we can see how to enable this plugin into an account as a user of an account. So for that, if we have our own account, we need to execute a transaction that calls the manager, and in this call, we are calling the function enable plugin, passing the plugin address we want to enable, and also a Boolean variable that is called allowed root access. What is root access? Well, we have defined 2 different levels of access, of permission, for plugins, for modules, and depending on if a plugin has root access or not, they will be able to execute certain transactions. Let's say a plugin does not have root access. This means they cannot execute delegate calls, and they cannot execute transactions where the destination is the manager or the safe. Why is that? Because if they were able to execute transactions where the destination is the manager or the safe, they would be able, from a plugin, to add new signers in the account or remove some signers from the account. And also, in the manager, they would be able to add more plugins or remove some plugins. So these kind of actions, we are just restricting them for plugins who have root access. In the future, this can be also be more granular, but for now, it is like a Boolean. Once we tell the manager that we want to add a plugin with a certain permission, the manager will call the registry that is attached to this manager and will check if the plugin exists there. If that's correct, then the manager will ask the plugin, hey, do you require root access or not? And then at the end of this flow, the manager will store in the storage, okay, this save or this account has enabled this plugin with this kind of permission. So that's it. Now we just need to know how to execute a transaction from a plugin. So let's see that. Now the flow starts from the plugin. Somebody's calling it, a method exec, let's say. And then the plugin, depending on the permission it has, it will call the manager, one of these two functions, execute root access or execute transaction. It's clear which one it is, I think, right? And we need to pass two properties, two parameters, save and transaction. Save is the account the plugin will be called, where this transaction will be executed. And the transaction is the transaction itself, but also some metadata that will provide some context of the plugin and the transaction. So now the manager knows what is the account that will be called and what is the transaction that will be executed. But first, it will check that the save has that plugin enabled and also that the plugin is added to the registry that is attached to the manager. There are two conditions here in the registry that need to happen. One is that the plugin is added to the registry, and the other one is that the plugin is not flagged. And what is being flagged? That means that owners can block plugins. If there's a vulnerability that is found, for example, the owner of a registry can say, okay, from now on, this plugin is not usable. So hackers could not exploit the plugin. This is a big advantage compared to enabling the plugins directly into the accounts, because when plugins are connected to the accounts directly, it's the responsibility of each owner of the account to disable the plugin before it is exploited, but here is the owner of the registry who can decide to block like everything at once, just for this plugin. So then, if in this flow where we are executing a transaction from the plugin, it is added to the registry, it is usable, it's not blocked, then the manager will check again what is the kind of permission the plugin requires. We'll check the storage. If it is the same, then the manager will finally tell the account to execute the transaction, calling the function exec transaction from module. So for all of these four components, we have defined interfaces. So we are offering a main implementation, but the protocol works with different implementations of these components as long as the interfaces are implemented. And here, for example, I will be showing the interfaces for the plugin and the manager that are the most useful for you, maybe. So the plugin needs to have like a name, a version, a metadata provider, so where to find this metadata structure, and then also if it requires root access or not. On the manager side, there are two functions you need to implement, so the plugin can call them, execute transaction and execute root access. To say something, execute transaction allows to batch multiple transactions and execute all of them at once, while execute root access just allows to execute one transaction at a time. Also in the manager, you can implement more functions that the ones defined in the interface. For example, how to enable plugins, disable plugins, get information from a plugin so you can create the storage. Now, some resources you can check regarding the Safecore protocol. We have 2 organizations on GitHub, the Safe-Global, and then 5AVE, which is more of, well, you will find more experimental things there. So in the first repository, the Safecore protocol, you can find all the interfaces and the contracts we have implemented, like the registry and the manager. Then there are some specs in the second one, some diagrams and flows that are useful to understand how it works. You can also find a demo, which is a React application that can be used inside our web app. And you can see a registry with multiple plugins there. You can enable, disable them. And also with the metadata, you can link URLs to these plugins so you can open their interface and operate with them. So the Safe Ecosystem Foundation has $10,000 up for grabs for hackers participating. And we have split this in 2. 5K for hackers, 5K in total for the 3 best projects building on top of the Safecore protocol, integrating or implementing any part of it. And then 5K in total for the 3 best projects working on the Safecore account abstraction SDK, integrating at least one of the existing kits we have. You can find us on Twitter @Safe. We have some docs, Discord, forum. So thank you very much. I don't know if we have time for questions. Otherwise, I'll be around. You can find us in the booth. Also will be available on the Discord for the hackathon. So thank you very much.
Can everybody hear me? All right, let's get started. I'm Jason Goldberg, founder and CEO of Airstack, and we have my co-founder Sarvesh here, and we're going to walk you through the AirStack platform in 20 minutes. So very simple, top level in AirStack is we enable Web3 composability. We're the easiest way to grab any type of on-chain transaction or data from across the Ethereum ecosystem and to plug it into your applications. And so if you look at this query, for instance, that I have here, you'll see how you can use our AI engine in a second to write queries. But this is a pretty complex query. This is asking, give me the wallet address and the ENS of holders of this NFT collection with a very specific NFT collection. Show the NFT image in medium size, return the token ID and the name from metadata. Also show their Farcaster and lens if they have one in XMTP. So we are going to just plug this into the AirStack AI. And so let's go here into the AirStack Studio. I'm just going to copy and paste this, and our AI engine actually helps you learn how to write the queries in AirStack. So the AirStack AI is trained on all of our APIs, and it'll write the GraphQL query for you, and then also deliver the response. You can, of course, add more variables to your query and write queries directly, which Sarvesh is going to show you. But what we did here is, in a matter of milliseconds, the AI has written a very complex query of, here's a very specific NFT collection, get me all the holders of that NFT collection, get me the images for the assets in that NFT collection, which we resize at AirStack for you with our CDN, get me all the details on the holders, including their lens or Farcaster ID if they have one, and whether they have XMTP or not. So really quickly, just to show you, these are all the APIs that we have at AirStack, or all the data points that you can bring back into your queries and response. And you can do all this in a single query and response. So you don't have to do, say, ping this API and then this API and this API. You can literally just do one API call, get back all this data. So I'll show you two more queries with the AI, and then Sarvesh is going to construct some manually and show you the details of how the APIs work. But way to think about it is, with AirStack, you have every ERC20, 721, 1155 on Ethereum and Polygon within seconds of the transaction finalizing. You have ERC 6551. If you're familiar with token-bound accounts, 6551. AirStack is the only indexer of 6551. You can index up and down the tree. You can even start off with an NFT that's, say, several layers below in the tree and say who's the owner of it, get the EO address of it. So we're also very strong in the areas of social and identity. So Lens, Farcaster, domains, ENS, both on-chain and off-chain ENS, as well as the only way that you can find out if someone has XMTP. So a lot of apps, specifically almost every major Lens app, is using AirStack to resolve what are basically people's ENS addresses to their to their lens name, to their 0x, so that the messages from XMTP get through, and you don't need to know someone's 0x address. Also, we do a lot with NFT market data as well. Let me just show you two more queries really quick in the AirStack Studio, and then Sarvesh will construct some from scratch. So I'm going to say, for instance, show you how complex you can do these composability. I'm going to do a query that says, show all attendees of ETHCC 6, which was a few weeks ago in Paris, and their Web3 socials and XMTP. And the AI is going to write this query for us. This is actually a really complex query. The ECC POAP is on the Gnosis chain. You have Web3 socials, Lens is on Polygon, Farcaster is on Optimism and off-chain and Farcaster hubs. XMTP is off-chain data. And the AI is able to write the query, and AirStack is able to give you back that response, all in the same response, a JSON file, where you see here's one user, their lens name, their lens handle, they have XMTP enabled. This person has a lens and a Farcaster. And so you can get all this back in your application very easily. Last one I'll show you is I can also say show all followers of BetaShop. This is me, betashop.lens. And if they have XMTP, and AirStack will go and grab my followers. It can be from Lens, can be from Farcaster, it can be both. So you can build interoperable applications and also see right away whether the user is messageable through XMTP. I'm going to find out what it is. My name is BetaShop9, sorry, on Lens. So we'll generate that again. And so here we have getting all the followers of BetaShop9.lens. Do they have XMTP enabled? And here you go. So here's all my followers. And you can see this person has XMTP enabled. You can also see their profile name, etc. Last thing I'll show you, then we hand to Sarvesh, is we have very robust documentation. We have everything from how to do combinations. So like show me everyone who, let's say, attended this event, or has this NFT and this NFT. Tokens in common. So let's say, do these two users both own this token? As I mentioned, 6551, XMTP, Lens, Farcaster, social follows, POAP, resolving identities, and you can also build very robust recommendation engines with AirStack as well. Last thing is we actually launched today with XMTP a number of spam filters. This is all about kind of proof of personhood. So like knowing, let's say you follow this person on Farcaster or Lens, so the message should get through into your primary inbox, or we know this is a real person because they attended an in-person event, or the high probability that you know this person. You both have attended multiple events together, or maybe both have high value NFTs together. Versus the inverse, this person looks like a likely spammer, so let's avoid them. So you can see all this in our docs, and I'm going to hand to Sarvesh, who's going to walk you through the details of how to build queries in AirStack more than I could in the 5-minute little razzle-dazzle I just did. Go ahead.
Thank you. Okay, let's get into it. Okay, so we'll start with the Explorer. So as you can see, we have many APIs here. I'll start with a simple one, which is token balances. So in this API, you can start from a token address, or you can start from a wallet. So from the token address, you will get the holders of the token, and from the wallet, you will find all the balances, right? So I'll build a simple query around it. So I'll select the amount and token ID, token type, right? And I'll take the address of the wallet, right? Now in the filter, I'll start with an ENS name. So I'll put my ENS name. And I'll run this query. So I'll get all the balances that I have, right? Now in the same query, if I see I have NFTs and I want to know the images of the NFTs, then I can select the token NFTs. I can go to content value. I can select different sizes of the images. I can run the query again. Then I get all the different sizes of images. I can also add more details to the same query. So I can add the social profiles. So I can select the dApp name and the profile name, and I can run the same query. So in the one query, I'm asking the socials as well along with the balances. Now in terms of input, you can start with the ENS, and you can also start with a lens profile. So if you have a lens profile, you can put a lens handle here, and you still get the same response. And if you have a Farcaster name, then you can put that too. Yeah. And you get the same response. So there's multiple ways to use this API, the token balances. You can build use cases like token gating around it. The next thing that I want to showcase is around socials. If you want to know about the social profile of a wallet. Yeah. So here we have identity as an input, so you can start with again an ENS name or a lens profile or a Farcaster name. You can select fields that you are interested in. I'll select a couple of them. So I'll select the dApp name, followers count, following count, and the profile name. All right. So this query gives me how many followers I have, how many people I follow. Now in the same query, if I want, I can add the list of the followers. So I can select the followers, and I can add the details about the follower. So I'll select the follower address, and I want to know, let's say, their social profile. So I can select the name and the dApp, right? See, so in the one query, I'm able to fetch all the followers for this identity. So this will give me followers across the protocols, and I'm able to ask the social profiles they have. If I want, I can add more details to it. So I can select the XMTP if they have XMTP. So if I have to build an app where I want to reach out to the followers and I want to use XMTP protocol, I can use this query. Okay, next I want to show about the POAPs. So I want to know what event particular identity attended. So I can start again with an ENS name, and I can select the fields. So I will select some details about the event. So the description of the event, the country where it happened. I can select the image for the event that was used in the POAPs, event name. Yeah, so I can run this query. Yeah, so you can see like I attended these events, and I able to fetch data around it. Right? If I have to ask like more details about the people who attended, right? So you can go again in the addresses, and you can ask like about their primary domain. So all the data is like connected with the wallet address, so you can go deeper and ask like more questions around it. Yeah. The next I'll cover like so we also have like token NFTs. In the token NFTs, you can go very detailed about the metadata, and you can query based on the metadata. Like if you want to find certain NFTs with the attributes, given attributes, so you want BAYC collection, and I want all the images, all the NFTs which has background blue. So you can build using this attribute. So you'll go here, and you can select the trait type as the background color, and you will select the value as blue. So you will be able to run those complex filters. Similarly, you have tokens and the balances too. Yeah. If you are interested into NFT sales data, then you start with the NFT sales transaction API. You can filter based on the token addresses and the token ID, and you can query all the sales data. It's coming from OpenSea, Blur, LooksRare, and Rarible. So 4 marketplaces you can get all the data around. So all of these are GraphQL APIs, and this you can use AI, or you can manually build the query. And once you have the query, there are multiple ways to use it. The one way is you can hit our GraphQL endpoint and put the query, and you'll get the response. We also have like SDKs. So you can, if you're building a front-end application, you can use React SDK. If you're building a back-end system, then you can use Node.js or Python SDK. We have a detailed examples on the GitHub. How do we use this SDK for all 3 languages? Yeah.
So just to show everyone real quick, we have a AirStack Explorer, which is a good example of how you can build very robust GUIs on top of the AirStack APIs without any backend at all. So this is a front end right on top of the AirStack. Actually, I'll use David. And this is a live API call. Did I spell your name right? Hold on. DAWFI.lens. There we go. So there's a microphone's in the way. That's just a live API call, and you have David's ERC 721s, 1155s, 6551s, and POAPs all in one view. You have the social profile, including all the followers. I can click in here, for example, and see everyone that David is following on Farcaster, including whether they have XMTP, Lens. I can also drill down on them and see how many of them also have Lens, actually who he's following on both Farcaster and Lens. And again, this is just live, like just ping our APIs in real time. And then you can even click out and just get the API for that, which opens up the studio where we just were a second ago. So it's really just that easy to build all sorts of front ends on top of this. You can use the SDKs, or you can use the APIs directly, as Sarvesh was saying. Any questions? I think we were pretty fast and efficient. Anyone? All right, we have a Telegram group for dev chat. You can get your free API key there, and our team is there 24/7 to ask if you have any questions. If you stop by our table, you can scan the QR code to get to our Telegram group, and yeah, and let us know. We'd love to help you build some amazing stuff this weekend, so let us know. Thank you. Appreciate it.
Hey everybody, thank you for joining our session. My name is Tylen, I'm with the Uniswap Foundation, and today we're going to be talking and introducing you to Uniswap v4. So before we start, I want to say welcome to where it all started for us. here in New York when all you could do on Uniswap was basically swap Uni for ETH. And safe to say, we've come a long way since then. And while we've done quite a bit, we're nowhere near being done. This summer, we announced the launch of Uniswap v4, or I should say we announced that Uniswap v4 will be launching, and with it came a very new and exciting paradigm for us, which we've introduced called hooks. Hooks allow you to now create pools that are customizable, they're modular, and they open up the design space for developers in a way that we haven't previously ever seen before at Uniswap and in DeFi. And I think it's a great, great time to be a developer on Uniswap. So hooks aren't the only new thing here. We've added so many new things to Uniswap v4 where you probably won't recognize, it's not the same things we saw at v3. Now we've moved to a singleton pool manager design. We've reintroduced native ETH. We have flash accounting. All of this is meant to make Uniswap faster, more gas efficient, and easier and more fun to build with for developers. Well, how about we dive into what makes v4 different? As we mentioned, the first thing we talked about was we have a different way for pools managing from Uniswap v3. In Uniswap v3, the way you would create pools is in a factory type style. You would end up going to the pool factory contract. The factory contract would then spin up a new, totally separate pool address for you, and the pools would all live separately in different addresses, and then you would have to call each of those addresses. So the way that works here is you set up your factory and pool manager contracts. You end up creating the contract factory and using that to interact with the pool creation. Then you would use that contract factory to deploy your Uniswap v3 contracts. When you deployed them, this is another thing. You only had 3 parameters that you really had to worry about. You worry about what pool pair you're doing, ETH USDC, and then you worry about what fee tier you have. In v3, you could choose from 4 fee tiers, and with that, came the automatic creation of what your tick spacing was. So your tick spacing is predetermined. You have your 3 parameters. Cool. And then you deploy your contract, you create the pool, and it's nice and done here, but it's in a different contract, which is not very easy if you're a developer to just keep on finding all these new contracts, interacting with them. It's kind of a pain. So what we did in v4 is we introduced a singleton style design, which is all of the pools now live in one contract, and they each have their own ID. And this ID is what you would use to reference the pool in the contract. So right off the bat, we're making it simpler. We're making it more gas efficient to also spin up pools. Now you don't have to deploy new contracts every time you spin up a pool. It all exists in the v4 pool manager. And the other thing that's different now is, as we saw in v3, there were only 3 parameters when it came to developing a pool. Now you have a bit more parameters. You still have your fee tiers and your currencies, but now fee tiers are basically customizable by you as the developer to any fee tier you want. No longer is it just 4 fee tiers. You can put anything you want. You can set your fee tier to 99% and see how many LPs will rush to that pool. The other thing is the tick spacing is now there and determined by you, and also new to the party, hooks. Hooks are their own separate contracts now that live in pools, and they're able to be customized, developed by you, and you could put whatever parameters you want around that, and it'll dictate how the pool performs. We'll dive into hooks a little bit later, but I think this is where you would be initializing the pool. You'd add your pool key here. It's all of the different parameters we just mentioned previously, and then you'd initialize this, and you would have your pool then saved into the contract. This is another interesting thing. This is where, before when you were initializing pools, you would not have the ability to actually have hooks on v3. Now in hooks, you can see when you're creating a pool, it checks to see if there's a hook that needs to be called before this pool is created. So that's already built into the initialize function. And then it's, as we mentioned, it's stored in the pool contract. The other item, no more wrapping of ETH needed. You can interact with native ETH, it's a lot easier, and I think developers, it's probably a lot easier for you for testing and for everything. So it's simplifying trading, it's reducing the costs, and welcome back, native ETH. The other item is flash accounting. Flash accounting's very important for us because now we're able to actually test out transactions and have them all happen in one batch while they're going through. So it's not, you're not wasting a lot of gas going through multiple different swaps, multiple different things. The lock and call function in our flash accounting allows you to basically lock together a transaction, test out the different swaps that are occurring, and it returns it looks at the delta of if everything adds up and makes sense. And for V4, this is super nice because, as we mentioned, like gas efficiency is a big thing that we've kind of cut down on, and this is what enables us to do this. Yeah, so here you have your account delta. You're checking to see if everything adds up, and it tracks all the balances to make sure that they're all accounted for and proper. And then you are able to get better results on your transactions and save more gas. Now that we've gotten all that, let's go to like the actual fun of everything here and why I think you as developers should be most excited. It's V4 hooks. So for the first time, you're now able to use Uniswap as a protocol and then build onto it new customizable features that could expand it from what it was as a DEX as just Uniswap to now your own customized DEX with your own customized pools, your own interface. So what it looks like is hooks can basically be called at 4 different action points within the Uniswap protocol. Before or after you create a pool, as we saw when we were initializing the pool, there was a hook to check, hey, do we call this hook here? Before or after a position is modified for an LP, so you're able to do cool things with that. You're able to call a hook before or after a swap occurs, and before or after donate. Donate is also a new feature in V4 where basically you can give fees to LPs who in a pool, basically donating to them, incentivizing them if they're probably staying within a certain range of liquidity, you can give them fees to maintain in that range. So there are lots of cool liquidity mining incentives that could be created from this. So let's take a look at what you can probably build as an example to make you understand how hooks perform. We're going to look at a simple New York Stock Exchange hook, right? What if I want to change Uniswap and make it only open during the hours of the New York Stock Exchange? So, we're going to look at this and we're going to say, okay, before a swap happens, I want to enable this hook and I want to check that this, I want to run my hook for this. So I call the before swap, I set that to true, and then I have my function in my separate hook contract that I add on to the Uniswap pool that I've created. So I have this ETHUSDC pool. It can only operate during the trading hours of the New York Stock Exchange. And before the swap occurs, I, as the swapper, now call this separate contract, or the contract now calls this separate contract, and it says, okay, is this between the hours of 8 o'clock and 5 p.m.? Is it a holiday? Is this, et cetera? And it checks to make sure that all of this is true. And if it is true, then the swap can occur. If it's not true, then the swap doesn't occur. And here, the developer actually emitted a ding, ding, ding whenever a swap happens, so you know that your swap has happened and the New York Stock Exchange bell has rang. Now, that's not the only type of hook you can build. Like, instead of the code, let's see other examples that might be more conceptual. What if now I have an NFT, and for whatever reason, I only want users of a certain NFT to be able to interact with my ETHUSDC pool? I, as the developer, say, okay, I have a Bored Ape NFT, and only people with the Bored Ape NFT can interact with this pool. And then we've got the EtherRock. We don't want the EtherRock people interacting with this pool. So this hook would create the same scenario where it checks before a swap happens if this condition is met, and it says the swap is successful. But if it's not met, then you can't swap on this pool. So there are lots of interesting social NFT type apps that can be built from this. And another, I think, more interesting app for people, or hook for people that are interested in the liquidity provision space is, what if now I have all of this liquidity in a USDC pool and I'm a provider of liquidity and I am not doing a great job of managing my positions. So I could create a hook that basically says, if this person is in range, they're obviously going to be doing well and they're going to be getting fees gathered, but what if my position is out of range? Well, you could create a hook that basically says, we're going to send any out of range liquidity to someone like Aave where we could still have yield being generated for us. So it's a way where hooks don't just have to be on the swap side. It's a very interesting way for you as developers to start thinking, how do I bring in more people into Uniswap, into this liquidity pool where we're able to do a lot more with their money and generate them fees in ways that hasn't been possible before on Uniswap. So that's Uniswap v4 as what we're doing with hooks. We have $20,000 in bounties that we're giving out for people that are looking to build on top of hooks. We call it our hookathon here. So we'll be giving $12,000 to people that, we're giving $12,000 as a pool prize to people that are building innovative, unique hooks that, you know, we haven't really seen before. And we haven't seen a lot of things because this has really been out for 2 months. So I think the world is y'all's oyster in how you build out these hooks. And because we're still building on top of the protocol, we are looking, because we're still building Uniswap v4 out, we're looking for any help with developer tooling, any things that help make the developer experience a lot better for us and for you guys. And we're giving out $3,000 in pool prizes for that. For each of the pool prizes, we're probably looking to give out 2 to 3 prizes. So you guys can deduce how much you can make from that. And then we have an open innovation prize at the end as well. This is $5,000, and it will be for anyone that builds on top of Uniswap v3 or v4. Eligibility to win these bounties is basically use the Uniswap v4 code, use the Uniswap v3 code. You know, don't just integrate like a swapping app. I think, you know, we'd like to see things that are a little bit more sophisticated than that. And if you are at all interested in continuing the discussion of v4 after this, come to me after this talk and join our Hook Dojo. We've got over 200 members in there that are active developers, building out hooks, sharing their ideas, answering questions. And I'm happy to give you guys the invite link. And then we also have our v4 docs. So just this week, we spun up a testnet, a roll-up on top of Optimism, where you're able to develop now much easier than deploying just on a local testnet. All of our information on how to do that is on there. And we are, we also have information on, you know, hook resources and how to start building with some example hook templates. With that, I am happy to answer any questions anybody has about the protocol. I wanted to leave more time for that. Yes?
Selection of the pool. I have a pool, and unsuspecting user tries to swap some. Do I have any guarantee that my pool is going to be used? Is there a fairness built into the v4?
Good question. So his question was basically, I've now created a pool with a hook. And me as a developer, how do I ensure that when someone is swapping, my pool gets routed to so that I can collect fees for my LPs on that pool? So that is a routing problem, which is, you know, dependent on, you know, dependent on the interface, dependent on like where you deploy your pools. It's I think it brings up like both a unique advantage where you can kind of have either, you know, we could go on to Uniswap X on how Uniswap X kind of addresses routing, but basically the short answer is like it does get a little tougher for pools to get picked up because we have to make sure that safety of pools for these protocols, it isn't stealing users' funds or doing something malicious. So there's still discussion on how we solve that right now, but for the most part, I think we might see some blend of some kind of hook list standards, some kind of protocols like taking the push on how do you actually like implement this into routing. So will labs like route to it automatically? I think that's still, we're still trying to figure that out.
How about Unity v4 user interface? Will that route?
That's still being figured out. Yeah. Cool, great question. Any other questions? Awesome. Well, thank you guys for your time. And yeah.
Welcome everyone. Today we're gonna do a short workshop on Scroll, how to get started to deploy on Scroll, and I'm gonna dive a little bit into the bridge of Scroll. If you don't know Scroll, you know it's a ZK rollup, a layer 2 solution to scale Ethereum. So zero knowledge and scaling Ethereum is what we're gonna talk about, and to Scroll. Short intro about myself. I'm Raza. I'm a developer relations at Scroll. So working to help developer get developer support and bridging our product to the community. So before I start, I just want to highlight the prize that we have. We've got a prize pool of 7K, which means that if you deploy a smart contract and verify it on chain through our block explorer, you'll get a part of the prize pool money. And next to that, we have 6 prizes. 3 prizes of 2K for the best teams out there, and 3 prizes for 1K per team for the runner-ups. Some of the criterias, you know, they must be deployed on our testnet and verified. It needs to have a working flow. By the way, you don't have to build like everything, but if you show a case of working flow, proper explanation, maybe of a problem that you're solving or a value that you are able to deliver, that's good enough. It's a hackathon at the end of the day. And, you know, it could also be super nerdy. That's we can definitely appreciate that. We also have postcards. So if you're looking, you know, shortcuts towards our guides, our docs, maybe some info about our prize money, or if you need a link towards our hacker Telegram group, we've got a group where we will share faucets. You can ping us. We'll come to you. You can come to our booth, and we're more than happy to help you if you're stuck, not just necessarily on deploying on Scroll, but anyhow, we can help. We've got full stack developers available. All right, without further ado, Scroll a ZK rollup. You know, Vitalik said zero knowledge is the holy grail of scaling solutions. And so, quick definition of what is a rollup. Like if you're active on crypto Twitter, you probably know the debate sometimes, but I'm just gonna summarize it real quick. You know, it's usually a second layer on top of a layer 1, batches transactions and post the data, the transactions on L1. Inherently, they try to solve the scalability issue. While L1, in this case Ethereum, needs to know that, hey, are these transactions valid? And for that, a proof is utilized. 2 types of proof today that are most popular: validity proofs and fraud proofs. I won't dive into fraud proofs. That's for optimistic rollups. But validity proofs utilized by ZK rollups. So a ZK rollup submits the transactions together with the proof. You know, a ZK rollup generates a zero knowledge proof, which is the validity proof, proving that the transactions are valid. And the proof is verified on a contract on L1. If this is just as context for a developer. Our goal for Scroll is that the developer experience is the same as Ethereum, meaning hard hat, Foundry, Brownies, unfortunately not maintained anymore, but 8. You can just, and Remix, you can just use it to deploy on Scroll. So without further ado, I kind of want to be hands-on and showcase to you guys, to everyone, how to deploy on Scroll. In order to do that, at first I'm going to go to Remix. It's a popular tool. If you're a beginner, it's a great place to start. And what I'll do is I'm going to go up over here. And this is a simple contract, a greeter contract that we'll utilize in a bit as well to showcase how to interact with the bridge. But utilizing Scroll is as simple as adding it to your MetaMask. So if you're not familiar with Chainlist, Chainlist is a great website where you can search for any network and then you can add it to MetaMask. I won't do it. I've already done that over here. But you can add MetaMask very easily with a couple of clicks. If you're wondering on using DevTool, which we'll do in a bit, we've got a developer quick start, where we also provide an RPC around all the necessary information. But to dive into it, it's really as simple as, so I have already added the network to my MetaMask, compiled the contract. So this is a very simple contract. And then when I go and hit deploy, I've chosen in my MetaMask wallet, click deploy, approve, and that's how simple it is for you to deploy your smart contract on Scroll. So look and feel the same. You can use Solidity. That's how easy it is. But probably most of you'll be hacking. You use Hard Hat or you'll use Foundry. both both work perfectly fine with Scroll. So over here, I've got a very simple contract in the Ether wallet, and what I can do is I'll open my terminal, and I'll do npx hard hat compile, which compiles the contract. Run the run command. Right. Forgot to install the. So if we do hard hat compile. Just going to go back to our quick start, which will showcase how to do this. Somehow running into an error. So over here, I've got a guide. I'll just follow it step by step to showcase how it works. So we can do this apparently together. So I've got over here my hard hat project, but I just need to install the dependencies. I'm having a bit of issues with that. In the meanwhile, what I'll do is I'll go back and dive into our bridge. This will take a while to install, and we'll get back to this in a minute. So what I want to do is dive into our bridges and showcase how our bridges work. Now, if you know a little bit about bridges, what it does is it serves you as a purpose that where you can basically interact from one chain to another. So you have a target chain and a source chain. So your source chain is where your data originates, any assets originates, and the target chain is where you want to, let's say, send your assets or your message or your data. And what we're going to do is send a message from L1 to L2 and vice versa. We'll do one where we send from L2 to L1, and I'll show you the distinct differences between the two. So if you're building any cross-chain application this weekend, this is probably very useful for you. So over here you see an overview where a user sends a message, so arbitrary data, to the Scroll messenger. That's how we called our bridge. And what happens is it gets appended to a so-called message queue and stored on chain on L1. And then we have a service running inside our sequencer on L2 that will pick up that message and then create the transaction and store it on L2. And what that looks like, I'll showcase it in Remix. So if I go back to Remix, what I have over here, and I won't redeploy it because it might take a bit time and internet can be laggy. So over here, I've got a greeter contract. Just gonna go back. So we'll be following this tutorial. So on one blockchain, we'll deploy, in this case, Sepolia, we'll deploy a greeter contract where we have a simple function that sets the greeting. So when we call this function, or in other case, the contract we will deploy on Scroll, when it's being called or a message is being sent, it will be stored inside this contract. So we'll send a message from L2 to L1. So this is the contract we'll deploy on L1, and we'll deploy a contract on L2 that will send the message. So in this case, over here, what I've got is a greeter contract, and I've already pre-deployed it, and then I'm going to showcase to you guys how it actually works. So what we need to do is we need to interact with the bridge. We start at L2, which means that we need to look at the smart contract that is on the L2 side. So if we go up, and over here we've got all the Scroll contracts in our docs. We scroll down. Remember, we're sending a message from L2 to L1, so we pick the Scroll messenger, which is the Scroll bridge, on L2, copy it, and then we paste it over here, which is exactly the same, which is the Scroll messenger. So now our smart contract, the operator on L2, will interact with the bridge. we want to send a message to L1. And what I did over here, I will scroll up. This smart contract is deployed on Sepolia. And so the target address is that smart contract. So we're over the bridge, we're sending that message. And then basically what I'm sending is a value of 0. So there's also a possibility to send, let's say, ETH or another form of asset, which we're not doing because this contract is not payable and we're just sending some arbitrary data. This is the greeting. I'll just change this slightly. And then there's a gas limit. I've upped it a lot just to make sure that it goes through, but 5,000 is more than enough. So when I do this, I'll go ahead and click change to, I'm on the scroll testnet. I'll transact, and transaction pops up. I'll confirm this, and then it hasn't gone through, so I'll just up the limit. That's very high, but and this is not going through at the moment. It seems like my contract is a bit buggy. All right, I'm just gonna showcase it on chain because I just did it before this tutorial, and then if you're working with it, make sure to find me at the booth. I'll just go back to explaining how it works from L2 to L1. When we send a message from L2 to L1, it's slightly different, being that when we send a message from L1 to L2, when we send a message, from L2 to L1, we need to make sure that Ethereum knows that the message that you've sent is valid. And so when it goes from L1 to L2, the message is quote unquote trusted because Sequencer listens to it, picks it up, and adds it to the transaction, and a ZK proof is generated. When the message is sent from L2 to L1, we need to make sure that L1 can trust that this message was indeed sent from Scroll, and that the user is allowed to withdraw it. So when we go down, I'm just going to go to the graph that I need. So what happens is, in the same way, the operator on L2, a message is created, it's sent to L1, and then what happens is our bridge API will generate a Merkle inclusion proof, and that Merkle inclusion proof can be utilized on L1 to withdraw the message from that smart contract. So when you take a look at our docs, it's going to go back. So when you send a message from L2 to L1, you basically generate the message in the same way. So you have a smart contract. Just going to hide this. So you have a smart contract, also a greeter operator that takes in the same parameters that you would have if the operator would be on L1. You would have the bridge contract that you pass, the target address, the value that you send. So you need to send a little bit ETH, and I'll explain in a bit why. You can send the arbitrary message and the gas limit. Now, when you send a message from L2 to L1, you need to send a little bit of ETH, and that's because when you send a message from L1 to L2, there's an automatic withdrawal. When you send a message from L2 to L1, there's no automatic withdrawal. Because again, L1 needs a proof in order to understand, hey, this user that wants to withdraw this message from L1 is allowed to do so, and then needs to pay a little bit of gas fees for that. So in this case, per our docs, once a message is sent from L2 to L1, you can go to Etherscan Sepolia, and it will take you over here to the bridge contract of scroll on L1. And what you pass here is data from the API. So if I open up my terminal, I've called this, and I did this before the workshop, because this can take a little bit of time, and I'll dive into that in a bit. What happens is you call this API with the smart contract of your operator on L2, and what it gives back is this long message, and over here you can see the proof that you need to pass, and along with all the other data. You can also call it in your browser. Once you've passed all of this data to this function on Etherscan, you could also obviously call it with your dev tooling or with web3.js or ethers.js. You can basically call this transaction, and what it will do is it will show you this is the example transaction. Here you could quote unquote withdraw as a user any arbitrary data that has been sent. Now, why do you need a Merkle inclusion proof, and how long does it take? Well, if you go to our docs, over here you'll see that the finalization can take up to an hour. And this has to do with the fact how a ZK rollup works. So when transactions are created on an L2, they're batched together, committed on L1. However, a ZK rollup also creates a validity proof. So what it does is it generates a proof for all these transactions and commits those transactions on chain. Commits the ZK proof for that on chain, and is being verified. And that whole process can take between 30 minutes up to an hour. And the trade-off here is that it might take up to an hour, and it might seem long. However, if you look at optimistic rollups, that's an arbitrary period, and that takes a lot more time. Some say 7 days, 14 days. It's really an arbitrary period. And so right now, the comparison is not necessarily instant versus 1 hour, but 1 hour versus that longer arbitrary period. So, in conclusion, please take a look at our docs, especially if you're going to do some cross-chain development. Apologies for the hiccups. Not sure what went wrong there, but we have a pretty well-written bridge documentation. If you're building cross-chain, if you need any help or any information, please visit the booth. Again, apologies for the hiccups, and not sure what went wrong on the dev tooling side. But I'll take any questions if there are any. Yeah, go ahead.
So we don't need a different, like when we compile our contracts for Ethereum, we don't need to recompile them for Sepolia.
No.
Okay, so we can just take that bytecode and directly throw it into Sepolia.
Yeah, if it's compiled already, then you can just throw it, yeah. Okay. Yeah, so again, not sure what happened wrong with that, but basically any dev tool that works on Ethereum works exactly the same on L2. If you already deployed the smart contract, and it's compiled to bytecode, then yeah, you could technically speaking pick up the bytecode, or you could just compile and deploy again, whatever you want. Yeah, it's just switching out the RPC URL. We've got our RPC URL available in our docs. The native currency of deploying on Scroll is ETH, so you need to bridge some ETH. However, if you don't want the bridge there, we've got faucets on in our docs as well. So if you go to the developer guides over here, and then developer quick start, you can find all the way down. We've got find me after the booth. I'll send it over. We've got faucets or the Telegram group, and we'll send it to you directly instead of you having to bridge it. Yeah, or Juan, who has a postcard, can give you one. All the details are on there. Yeah, go ahead.
Does Scroll support all opcodes? Which ones does it not support?
Ha ha ha. Yeah. Well, you're really catching me off guard. This is not my day. Okay. We're very open about it, to be quite frank. So I can show to you, the Ethereum Scroll differences. So there are, let's say, some quote-unquote ZK unfriendly opcodes, and I guess the most famous one, SHA-256. and then RAPMD, and then we also Blake 2F. These are currently not supported. Yeah, so they will be supported in the future. So for anyone who's like wondering, you know, and not entirely familiar with precompiles, what a ZK rollup does is it basically proves that the smart contract behaves exactly like Ethereum. And to do that, I can show it. We've got a little bit more time. To do that, basically what it does is it gets the execution trace. Execution trace meaning like exactly step by step how the smart contract would be executed on a virtual machine. So what happens over here? This is the sequencer. You know, just like I said, any RPC, you know, an RPC URL. So this is our get node. Over here, you deploy it, and then the coordinator checks with the sequencer what the execution trace is. And in that execution trace, it has all the opcodes and bytecodes. So the bytecode, and then it says like, you know, push, you know, add, stack, etc. However, precompiles work slightly different because, you know, they are sets of instructions that Ethereum has identified and said, okay, hey, you know, these are executed in a certain way, so they're already quote unquote precompiled, or you know, they are complex hashing functions such as SHA-256. The ZK circuits are custom tailored to prove these opcodes. So there we have many tables for that. So this is the long answer. And so in order to prove that this opcode behaves exactly in a certain way, we have a circuit that does that. Many circuits that do that combine into a proof, and then basically we're able to say, hey, this smart contract operates in the right way. Now, the limitations of a ZK circuit are far more than Ethereum. You can go up to 56 bits words versus 32. So that's one of the limitations where a ZK circuit has difficulty. Or the factual answer would be it takes a long time to prove it, so the proving overhead goes up. So in order to keep proving times under a certain limit and also gas price, you know, we right now currently don't support it, but we will in the future. Sorry, long answer, but yeah. Any other mean questions? I'm just joking, man. Like, you're good. Yeah. You can jab. Like the fact that I couldn't like show a hard head, that's like so bad. But you know. No. Yeah. Go ahead. No, that's a Brownie thing. So Brownie is not being maintained anymore. Yeah, but Brownie is supported. I can give you a couple of guys. No, Brownie is not maintained. So ApeWorks is building Ape. So the Python framework to develop in right now would be Ape. It looks and feels and works the same. All right. Well, thanks a lot, guys.
Test, 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 test. Hey everyone, all right, looks like we got the audio, 6 o'clock. I'm gonna go ahead and get started. My name is Zach Ayash. I'm with the developer relations team with the Filecoin Virtual Machine and Protocol Labs. And so today I'm gonna give you an overview of IPFS, Filecoin, the FVM, and data DAOs, which are exciting new application that we're seeing a lot of interest in and people building on, right? So without further ado, I'll go ahead and get into it. Also, real quick, an aside, usually I have a slide for this, but I had a lot of slides and I don't want to fit it in. But, you know, a lot of the stuff I'm saying, you know, I'm going to try to build up from the ground up, but if something doesn't make sense, it probably doesn't make sense for a lot of people. So feel free to ask a question if we have time after. If not, you'll find me at the booth or find anyone with a yellow jacket and the Filecoin symbol on, and you can ask them questions, right? So let's dive in, the Filecoin master plan. So step one, build the world's largest decentralized storage network. That's checked off. I believe last I checked, there is exabytes of storage capacity for the Filecoin network. So already pretty large. Step two, onboard and safeguard humanity's data. What is humanity's data? That is all the data that humanity finds useful, which is a lot of data, right? This is something that will continue to happen, you know, as we as humans generate more and more data. And finally, step three is bring compute to the data and enable web scale apps in a decentralized way, right? And this is where the Filecoin virtual machine comes in, and we'll jump into that in a second, right? So you heard that I work specifically with the Filecoin virtual machine team. What is the FVM? It delivers on-chain programmability to the Filecoin network. The Filecoin blockchain was an application-specific blockchain initially designed to be like a middle layer between clients that had data they want archivally stored and storage providers that had large amounts of SSD and are willing to provide that for a price, right? The Filecoin virtual machine allows us to write programs, or as you may know them, smart contracts, on top of the Filecoin virtual machine, and allows us to design programmability. And we'll get into what makes it special on Filecoin versus like a traditional EVM chain in a second. So the most common question and confusions that we get are between IPFS and Filecoin, right? A lot of developers know IPFS, a little less know Filecoin, and a lot of people want to know what is the difference, right? Some people heard Filecoin is an incentivization layer on top of IPFS. That is incorrect. IPFS and Filecoin are two separate networks. IPFS is a peer-to-peer storage and file sharing network, much like BitTorrent. Only the content is content address, right? Not location address. So like BitTorrent, you need a file to get started. In IPFS, you look up your content by what's called a CID, which is basically like a hash of your data that represents your data, right? The thing with IPFS is you don't have permanent storage on it, right? Like there's nothing that guarantees your data is going to stay up if people just don't have it pinned up, right? So this is where the Filecoin blockchain comes into play. And we have it kind of divvied out into layers. Layer 0, you can think of it as the storage layer. This is the storage providers providing their SSDs and validating the blockchain. They have layer 1 as the FVM. It's kind of like a layer 0.5, as we'll see in a second. It's actually within the layer 0. It's within the Filecoin chain, right? The virtual machine lives in the Filecoin blockchain, and all the storage providers run it. And you can think of layer 2 as any storage-related dApps and solutions built on top of the Filecoin blockchain, including what other chains call layer 2. So other blockchains could plug in to the Filecoin blockchain to help it scale, right? So again, to kind of like illustrate IPFS a little bit more, if you want to use IPFS and give a little bit more guarantees, a client, you can run a bunch of your own nodes to add a little bit more availability guarantees for the data that you store in IPFS. You can run nodes with the community, which would probably be even better, right? If it's like really in-demand data, people may want to host it themselves and make it super available. Or you can pay for a pinning service, and they'll give you some reliability guarantees. But this is obviously a slightly more centralized solution, right? And so all of these are basically based off either you're kind of paying for a centralized solution, or you're hoping for the goodwill of the community to keep the data alive, which I think works as an awesome protocol, but if you really just need those guarantees that that data is going to be there, and you want those guarantees in a decentralized way, Filecoin is going to need to come in, right? So here's like kind of a simple illustration of the Filecoin network. You have storage providers there on the bottom, and they are running the Filecoin chain nodes, the client software. One of the biggest ones is Lotus. This would be kind of like the equivalent of like Geth, if you're familiar with Ethereum clients for Filecoin. So these storage providers, they have a lot of SSDs, typically warehouses of them, but anyone can become one of these storage providers. You just need SSDs to provide storage. They put some fill as collateral to become a validator. And they run the Filecoin blockchain. This logical thing that is the Filecoin blockchain runs on all of these storage providers, right? And they have to come to consensus on blocks, like any other blockchain, right? Again, originally the Filecoin blockchain was tailor-made to sit in between the storage providers and clients up there who want their data stored, right? And that's just kind of what it was made for. But beginning in March, a virtual machine was added into the Filecoin blockchain, right? The Filecoin virtual machine. It was clear, with all of these virtual machines and smart contracts, that this kind of programmability capability on blockchains is super useful to have, right? Smart contracts enable you to build decentralized logic. Now we'll get into it, but like with Filecoin, we can build logic around storage, right? So within that blockchain sits the virtual machine. And to give you a little background on exactly what the architecture of the FVM looks like, those storage providers, right? They're all running a blockchain node, most likely a Lotus node, which is the most popular. There's also Venus. And within that Filecoin node, you have the FVM that kind of sits within it. It is built in a WASM-based runtime. And the EVM is actually virtualized on top of this WASM-based virtual machine. So you may be asking, why are we virtualizing the EVM on top of WASM instead of just using WASM or just using the EVM, right? One of the core reasons is that it's still unclear, even though EVM is the predominant virtual machine in Web3 at the moment, what virtual machine is really going to be the one that takes off in the future. And this allows flexibility for adding other runtimes, other virtual machines to the Filecoin blockchain if needed in the future, right? Right now, the first one is EVM. It's fully EVM compatible. Later down the line, we could add new foreign blockchain runtimes, like maybe the Solana runtime could run in Filecoin, and even a possibility of non-blockchain runtimes. For whatever reason, maybe we want to run the JVM in Filecoin. You could technically do that, right? We also have this concept of built-in actors, kind of like precompiles in Ethereum. These are the traditional APIs in Filecoin that you would use to make storage deals. And we'll get into it, but you can actually access these inbuilt actors from within the EVM in Filecoin. So again, EVM is the first runtime, fully EVM compatible. So all of your favorite tools, if you're used to developing on the EVM, are totally usable for developing on Filecoin. Hardhat, can't say Truffle anymore, but Foundry, MetaMask, Remix. So we have some pre-built kits that you can use, and I'll provide links to that in a bit. But yeah, so you can build with it, and that's one of the main reasons the EVM was the first, right? Because everyone is familiar with it. It has the most robust developer ecosystem out of all the Web3 EVMs so far. So, next common question we would naturally get is, why should I use the FVM, right? There's a million EVM chains. Why don't I just use Ethereum itself, Arbitrum, Polygon, name your favorite EVM chain. Why not that? There's a simple answer to that, and it's storage deals, right? This concept of storage deals, which don't exist on almost any other blockchain that I'm familiar with, right? So, what is a storage deal, right? Storage deals are the contracts that govern those storage providers that we're talking about, right? So, we said earlier, IPFS doesn't incentivize storage, Filecoin does. How does it do that? Well, if you're running a storage provider node, you have to put up collateral, right, in Filecoin token, right, to run the node, right? And if you take a storage deal, you have to put up a little bit more collateral per the deal, right? And once you do that as a storage provider, you do what's called seal the data. And every 24 hours, you have to provide a proof that you are still storing that data. If you fail to provide a proof, your collateral can get slashed, right? So if you do provide the proof, you continue to get paid as per the storage deal, right? And these storage deals live on the Filecoin blockchain, right? We'll get in, like another common misconception is the data that we're storing like the large data sets that we're storing with these storage providers, they do not live on chain, right? This is what lives on chain, like the storage deals, the metadata, you know, saying who's storing what, how big the data is it verified with fill plus, kind of the metadata of the data, right? But the storage providers have the actual large data sets in their hard drive sealed and ready to be proved at any point. So again, you know, so the FVM cannot actually compute over these large data sets stored with the storage providers. There's other networks that can do that. You know, off-chain networks, it'd be really expensive to do that in a blockchain virtual machine. Storage deals are the contracts metadata that represents that data. So just really want to beat that point in because that's the first thing people want. It's like, okay, I've got data stored with these storage providers. I want to run an AI model over it. You can do that, but just not with the FVM. With something like Bakilao or Lilypad, our projects that are kind of building on top of that allow you to do that. So we talked about you know, these inbuilt actors and how, you know, Filecoin, the blockchain, kind of predates the virtual machine. The virtual machine launched on mainnet back in March. And so, you know, there's all these classic APIs that were available before the virtual machine. How do we access those APIs from Solidity, from the EVM on Filecoin, right? Because the EVM wasn't built, again, knowing what a storage deal is. It doesn't know how to access those things. And that's really what makes the Filecoin EVM unique. So we worked together with a wonderful team, Zondax, to build these Filecoin Solidity libraries, which act as abstractions between these inbuilt actors. So you can easily access these APIs from these built-in actors in your Solidity smart contracts, right? So if you want to read those storage deals, you can do so through filecoin.sol, right? If you want to read what miner has what deal, you can do that through filecoin.sol and start writing unique application, storage-based applications with it. Right, so there's kind of three main paths where we're pushing people on how to get your data stored on Filecoin, right? Maybe you don't need any kind of programmatic storage. And in that case, you can just store data like you could always on Filecoin, which usually involves getting to know a storage provider or finding them on some marketplace, seeing what kind of deals they're accepting, signing what we call a deal proposal with a key. The storage provider will review that. They will decide if that's a valuable deal or not, and you know, you can negotiate. But if it is, they'll call a method called publish storage deal on chain, and your deal will get active, and they'll store your deal, and they'll start having to make proofs, right? But maybe you need programmatic storage. In that case, there's two paths. If you have really small data sets, maybe just a couple of NFT images, or maybe you have a really large data set, like huge DSI data sets, like oceanographic data or something that you want to run a large AI model on. If you have the small data, and for many people building in this hackathon, you'll probably be working with smaller data sets, we recommend you use an aggregator, basically a third party that will take your data, they'll put it on IPFS, and they'll work on making a storage deal for you on Filecoin. All the complexity is abstracted away, super easy, super quick. The other option is using what we call the client contract, basically a contract which allows you to make a storage deal completely on chain. It does this by an emitting event with all of the deal proposal informations, and any storage provider running a front end called Boost can listen for that event information and make the deal through that, right? The client contract is a bit more complex, so a lot of the aggregators, they use this in the background themselves. So it's a lot harder to get started for like a quick weekend hackathon. So I definitely suggest checking out the aggregator route. But if you really want to, you can find the client contract. It's in our starter kits, and you can kind of start developing with that. So yep, 3 paths. So what can you do with the FEM, right? You can kind of do what you do with any other virtual machine in Web3. We can make governance. You can mint tokens to give your project tokenomics, endowment management. But we also have these like kind of fundamental infrastructure things we can now build, right? Repair workers, renew workers. So before in Filecoin, if your deal that you would make would have a certain amount of time and then it would expire, right? But maybe you want to have your deal renew on indefinitely, right? In this case, you could maybe create a DAO, and that DAO can fund a treasury, and that treasury can be used to pay renew workers that monitor the state of a deal and automatically renew it for you when it's about to expire. And this way you can kind of crowdfund a deal that just kind of keeps the data stored indefinitely, right? Or make new storage deals, right? These are kind of primitives that you wouldn't really see in another chain that doesn't have storage at its kind of base layer. So what are data DAOs? That's a term that was kind of in the title of the talk. It's kind of a buzzword you'll see around. If you're not familiar, a DAO stands for Decentralized Autonomous Organization. Essentially, it's just a bunch of people organizing on-chain and figuring out a way to vote for proposals and get things passed. Data is this boring definition, a collection of discrete values. I basically put up there just to be a little facetious. I think we all know what data is. Well, what I mean when I'm saying data DAOs is DAOs storing data on Filecoin, right? You'll kind of see this term used different ways in different places, and it's still kind of a nebulous term depending on who you talk to, but this is what I mean specifically when I talk about data DAOs, right? So DAOs that are kind of managing the data being stored on Filecoin. So I have a fun example of a DAO that my colleague Sarah came up with. Botkit DAO. If you don't know, Botkit is the mascot for Filecoin. It's the corgi. And Botkit DAO is a community of corgi dog owners that want to better understand their corgis and let the world better understand corgis, right? So, maybe they have some ZK verified access as a contributor. Maybe it's open. And they upload corgi behavior Monday to Friday on the Filecoin chain, and as a reward, they get tokens, some kind of Botkit token maybe, that they can use to further vote in the DAO. It could have value. They can sell in the open market. But as more corgi owners get more tokens, they can participate in DAO votings, and they can use like the treasury of the DAO to further incentivize specific kind of data sets they need on their corgis, control the treasury, reward, maybe take some of that money, donate it to organizations that will rescue corgis. Whatever the DAO wants, they can now organize around that. They could also use the tokens to maybe pay for a service like Bacalao or Lilypad and run some AI models over this data to get some more refined information on all the corgis in the DAO, right? And again, they can also fund these repair, renew, replicate deals to make sure that their data is stored indefinitely. And this results in healthier and happier corgis around the world. And who doesn't want healthier and happy corgis? You can replace it with a cat if you're more of a cat person, or any other breed of dog. But this is kind of just a fun example to show you like what you could possibly build with FVM and data DAOs. Hot off the presses, I actually just pushed an example of Botkit DAO onto the Filecoin and Protocol Labs GitHub repo, right? So you can check it out. It has a bunch of contracts in it already. It allows you to basically go in, make a proposal for data that you have stored on Filecoin, right? And you can actually store that data quickly and easily using an aggregator, lighthouse.storage, and rewards tokens out if the DAO votes on yeah, this is data that we want, this is data that's stored, And it has a README that kind of explains it. I'll be kind of building up this more in my free time, just giving it maybe more of a front end. So this is kind of still an MVP right now, but it has everything you need to experiment and play around with a Botkit DAO. Right, and you've heard me talk about aggregators, and Lighthouse as Storage is an aggregator we've been working closely with. They have an awesome team, and the kit actually uses their SDK to store the data, so I'd highly recommend checking out lighthouse.storage. They also offer all kinds of cool functionality and documentation, including an interesting feature called PodSci, which in a nutshell lets you know if you have this big aggregated data stored on Filecoin, is my data within that data? Normally you wouldn't know, but they provide a data proof so you can find what deal your data is actually stored in. And for more generically, we had Botkit DAO as an example DAO. We have a data DAO kit that has all of the generic boilerplate pieces from like OpenZeppelin you may need to build a data DAO. A lot less opinionated, just kind of there with some basic examples and scripts you can look at. It was based on an old colleague of mine, Patrick Collins. He has a great video on DAOs in general and explaining them. I actually linked to that video in the README, so I'd highly suggest watching that video if you just want to know what all the contracts in the DAO do and learn a little bit more. Yeah, and so if you want any more FVM resources, you can check out our link tree. It'll point you to the docs. All of those kits I've mentioned are forums on GitHub where you can ask questions. Yeah, so very nifty link tree. And I believe Sarah will be presenting a little bit more detail on these bounties at 8, but we do have bounties for this hackathon, so 20K of bounties. You see we have a grand prize and a pool prize. And some interesting project ideas that we're looking for. Of course, I've mentioned data DAOs, and we've provided some resources for those. DeFi projects, still always welcome. Programmable storage markets. I think this is something very unique, and this is something you really can't do on many other chains. Tools, infra, and bridging, always welcome. And compute over data with Lilypad. Bacula and Lilypad is that heavy compute framework I've mentioned several times. If you have questions about that, I highly suggest you check out their documentation and their Slack channels. But yeah, these are some project ideas if you were still wondering. So with that, I believe I have 5 minutes for a Q&A. So if anyone has any questions, feel free to raise your hand and ask them now. Yeah, we have one.
So do you have interoperability with NPM and other EVM?
Yeah, so you asked if we have interoperability with FVM and Cosmos VM, right? Cosmos uses Cosmwasm at the base, I believe. So no, right now, the only runtime we have is EVM, right? So anything you write in Solidity can be put there, or anything that compiles to EVM bytecode, Viper as well. But not anything with Cosmos, I believe, directly.
I think there are like hyperlink and some like there are some kind of bridge ecosystem. We don't have a bridge ecosystem. We can have interoperability.
Yeah, if you use a bridge, you can interoperate with Cosmos, right? And there is, like I know Axelar we work with, they help bridge between like Ethereum and the Filecoin blockchain, and yeah, bridges will allow you to do that. And you can build any kind of bridge you want on FVM. Any other questions? Going once. Going twice. All right, well, if you do have any other questions later, feel free to find me or any of my colleagues in the yellow vests at the Filecoin booth. We stick out like sore thumbs, so shouldn't be too hard to find us. And please feel free to badger us with any questions you have. We'd be happy to answer. thanks for listening, and thanks to ETHGlobal for hosting this event. Looking forward to seeing what y'all build. So have a good night.